Today is June 12th, 2017. I'm Gunter Steinbach, and I'm interviewing Dr. Ted Selker at the Computer History Museum in Mountain View. I started contact with you because you invented TrackPoint that was or is in many laptops, especially by IBM. But this oral history interview is about all of your work and career, not just about that. So let's start with the beginning. Like, where did you grow up? What was your family background, your childhood hobbies, and so on?
Okay. Well, I'm born to a Holocaust survivor. My mother came to this country and met my father in Washington, D.C., and they moved a couple times. My dad was a chemical engineer, and I was born in Spokane, Washington, and spent all of my childhood in the state of Washington. Beautiful place, oh my God, and learned to love the outdoors. And my father was just intellectually extremely curious, and I was very intrigued by the fact that his father, my grandfather, had invented the shock absorber for cars. And I never got to meet him. All my grandparents were dead by the time I came along. But that is kind of a beginning of what kind of became my lifelong love affair of innovation and invention. So I lived in Seattle for 6 years, and then Tacoma, and then Longview is where I went to high school. Yeah.
And so I guess that background got you into engineering. You could be creative in other ways too, but...
Well, I mean, when I was very, very small, I was just fascinated with electricity. What's interesting about what surprised me was that I could plug in a lamp anywhere and it would always work. These outlets are standard, obviously, and I was 2 or 3 at that time. So I started being interested in electricity, and that's something that's been a lifelong interest. I tried to build things on my own, and was discovered at a electronics parts store when I was 11 by a TV repair person who took me under his wing and taught me all about fixing television. So that's kind of part of that excursion.
I had a time like that too.
Yeah, so much fun.
Okay, so let's talk about your college degrees. Where did you get your college degrees?
Yeah, well, so when
not in Washington.
No.
Right.
Well, I started. All my brothers went to Reed College, so I decided to be an iconoclast because they saw the spelling errors in my application and weren't going to give me a scholarship. So my father wanted me to go to Reed anyway, and I went to University of Washington one year. But basically, when I was 16, my dad told me, well, you're interested in applied math, but Brown's the best school in the country. You couldn't get in. So that's where I went. I transferred there and got my degree from Brown. And I was interested in, I wrote an undergraduate thesis on how eyes focus, and I got interested in this idea of maybe a camera could automatically frame things. And there was this research project going on at UMass Amherst that this guy gave a talk at Brown just in my senior spring year, and then he sent me this love letter basically saying, come to my university and we'll pay for your degree. So I was going to go work on Visions, which was this automatic image understanding stuff. And so I have a master's degree from there, but quite frankly, I felt like UMass was not as exciting as Silicon Valley. And so after a year and a half, I kind of transferred, 2 years, I transferred to working at Stanford.
Okay.
Yeah, lots else happened.
But you did not get your Ph.D. at Stanford.
No, I did not, and that's interesting. What happened was, instead of transferring to Stanford, I thought it'd be easier to be a visiting student, but I was less and less happy with the advisors at UMass Amherst, and there was no user interface research going on, which I was fascinated by, at any university. I started a seminar series called User System Ergonomics Research at User System Ergonomics at Stanford. Once a week, I'd try to get people together, and it was like, you know, Von Pratt came, by the way, and John McCarthy. Those are the two faculty members. But it was before Terry Winograd got interested in user interface. And all the people were coming from Atari, PARC, SRI. So I said, you know what? I'm going to go work for Alan Kay at Atari, where the action is. And I quit graduate school and went to work for Atari. That was not a way to get a PhD at that moment because Atari didn't last. And so quite explicitly, a year and a half later when I was working at Xerox PARC, I decided if I want to get a PhD, if I want to have impact at a place like PARC, I got to get my PhD. And my dad had always pushed me, or he'd always wanted a PhD and hadn't got one. So I turned down all sorts of wonderful experiences to get my PhD. But one of them was to not go to Sun and instead go to IBM. And at IBM, they gave me tremendous resources and freedom to do all sorts of stuff. And my real dream there, why I was going there, was to get my PhD.
Oh, okay.
And so I thought it'd take 3 years. It took 7. But my degree then is from City University of New York.
Okay.
Because a very dear man named Efren Feig, who's still a brilliant scientist, saw that if I didn't work on my PhD, I was going to leave. And so he hooked me up with City University, and yeah, that's where I got my degree.
Okay. All right, so what did you work on at Atari then?
Oh my gosh. Well, my Lisp machine's name was Intelligent Interface, and I dreamt of making AI-based teaching systems, and that's what I said I was going to do.
Okay. At Atari.
At Atari.
I guess they made general purpose personal computers too, right?
They
Not
made,
just video games.
well, this research center was something to behold. I mean, Alan Kay ran it, you know, Doug Lynott, Marvin Minsky,
Oh, really?
Alan Kay, yeah, there was Terry Winograd, everybody came by. It was such a party, and it was inhabited by people that were the first graduates from Architecture Machine Group at MIT. So we could do anything, supposedly. And I worked on, I made a force feedback ski boot, and I had this idea of teaching people with cerebral palsy, maybe teaching people to ski.
Oh.
It was pneumatic, it ran off an Atari 800. And I had this idea, which I still haven't realized, I don't have a little part of it with me, Dreamwriter. Dreamwriter was something, it was, in fact, it was the way I met Marvin, it was in 1982, I showed him this mock-up I'd made of a pen that would draw in any font and draw anything on a piece of paper. And so you could rub it out, would come a picture of your wife. Or you know, if you took notes, they'd be collected. And if you wanted to address an envelope, it would come out in Helvetica, you know, 10-point.
Oh.
This was my dream, and I did many explorations about this at Atari and before, but mostly at Atari. And I still kind of love this dream. And there was this guy, Jim Dow, who started a company called Communications Intelligence Corporation. I don't know if he's still alive. He was really quite amazing. He made a lot of the semiconductor industries. He made his millions by making, you know, epitaxial, you know, etching things. Very first generation. And he was really intrigued with this idea and interested in me going to work for him to make it. And that's a sad non-direction I went, but because I think it was really kind of exciting. Anyway, at Atari, it was shoot for the moon, and quite frankly, my intelligent interface work was in my mind, but there wasn't much code written on that.
And then Atari blew up,
Yeah,
I guess.
Atari, in March, I'd been there 9 months, and it's so interesting, the way to watch how businesses work. That company had gone from 1979, 8, nothing to $1 billion a year in 83, to $2 billion a year in 83. That's such a climb. And then 1 billion in 84 killed it. So it's amazing that, it's funny that it's the trajectory. I mean, $1 billion is a lot of money. Basically, Coleco and TI and Sinclair, and everybody wanted to make, these personal computers and game computers, but mostly the personal computers, which was Atari. They lived and died by computer games, and everybody else was trying it out, and the market went down, and it was very, very sad. We had the most incredible organization working on so many exciting things.
But the name still exists.
Atari. I should wear my T-shirt. Yeah, I mean, and quite frankly, I mean, one of the people that I think has been a lot of fun for me to get to know better over the years. He wasn't there at the time. Is Nolan Bushnell. He is quite a showman, and really, I think, quite a visionary that guided all of that to happen. Before he left before any of this, the badness.
Oh, really?
Oh, yeah. He hadn't been there in at least 2-3 years. He left, I think, 81.
Okay. Yeah. Okay, so when that
Sad.
blew up,
Yeah.
when it, what did you do then?
So that was a fascinating thing, because I mean, there I was, all of the ambition still, and all at once, Rod Brooks, who ran the AI lab at MIT, was leaving Stanford to go to MIT, and so he was supposed to teach the AI and Lisp class that fall. Which is the same one that Udacity was created out of. And I got offered the job. So I got to be the lecturer to teach AI and Lisp that fall. And instead of doing something reasonable, I made a whole new curriculum about AI in education. And I taught all of these modules. I made a Windows system for the VT100 that they were supposed to do this, using Lisp, supposed to make this intelligent tutoring system that taught Lisp. And since I had 120 students, half of them far-flung as, Colorado, I teamed them up into groups of 3 to each of them make competing help systems using, Blackboard architectures and rule-based systems and some learning, hopefully, and taught these topics. And that, quite frankly, became where I learned some very, very exciting things about the problems of changing what a person sees when they do something. If you have an AI system that changes what it does, it confuses people. So I really learned so much of what I needed to know to make my Ph.D. work on AI and education out of teaching that class, which was really great fun. Very non-lucrative. I've never in my life, except for during that semester, borrowed money from my father, period. So very, very, very bad thing to try to make money as a lecturer at Stanford. Bad.
Okay, so at what point did you go to PARC?
Well, this course was as I said, not lucrative, and so there were 2 things I did beyond the lecturing. One is get to know people at PARC, because I always adored their work, And they got interested in me because I had built a collaborative computing system at Stanford AI Lab when I was a graduate student there. I made this thing called Nudity, actually. It was the new data disk. And they were trying to make a collaborative environment. It was a room with special furniture, beautiful thing. Mark Stefik, Danny Bobrow, rest in peace. And so I got interested in them, and about a month after I finished my teaching at Stanford, I was working there. I also, in that time frame, got more involved with the Veterans Administration Hospital research on people with disabilities, and I consulted for them. The funny thing about that is the first talk that I ever got paid to give was 2 or 3 years earlier, when I gave this talk about AI and disabilities for some reason, and Larry Leifer, still a professor at Stanford, paid me, thank you, to give a talk about intelligent interface. So that was the beginning of my that direction.
Your speaking career.
Yeah.
Okay, but so
mostly paid about like this is.
I found one patent at PARC about a pen mouse.
Oh, really?
Yes.
That patent is fascinating. It was not, actually that pen mouse was not a PARC patent. It was a patent that I paid for.
Oh, okay.
And what's really silly is I didn't pursue people that used it. And what's really the fascinating thing about a mouse, there's lots of good things about a mouse. A mouse, I've thought a lot about pointing devices. A mouse, you can control it with your arm, and you control it with your fingers. If you put the heel of your hand down, get lots of accuracy. But your hands are so far apart. So actually, one thing I did make at PARC was a mouse where you could hold it very, very close together with the dexterity of your fingers. And Stuart Card still has that mouse, but I just made it in my spare time. But what I dreamt of was a stylus that you would that would not fall over. So many years later, I made this one, but at that time, that patent was about a mouse that would not fall over. And what would be good about that is you see, the reason mice are great is they don't move when you let go of them, whereas picking up a pen is kind of difficult. So, and then you've got like 45 muscles all working together, enlisting each other to pet work. You've spent years learning how to be really dexterous with this. So this one, on a TrackPoint, I actually made and used this keyboard for many years. Tried to get IBM to do it. So there was going to be a pointing device in the middle, and then you could grab this straw and wiggle it, and then it'd fold down when you close the laptop. But it was always there if you wanted to grab and write it and sign or do something really careful. But by being in a location that is recognizable and findable, you can save yourself a lot of energy and time. And I really believe that the several seconds that it takes to pick up a pen is the reason that mice are one of the brilliant things about a mouse, is it not falling down. So that was that patent. And sadly, I was at IBM and felt a little shy about pursuing litigation or business opportunities outside of IBM relating to my patent. So thank you for finding that patent. I'm very proud of that one, actually.
Okay. So you pretty soon, you didn't stay at PARC very long.
No, I was there 9 months and loved it. I built something called, I made this automatic graphic design approach that was showing off some of the language features of InterLisp-D with loops. And I was supporting physically making interfaces for this big collaborative space. So I've always had this dance that goes mechanical, electrical, computer, AI. It's about me having a love for understanding all of technology in order to use the correct or useful techniques for a specific solution. And they liked that. But what they didn't like is I didn't have a Ph.D. And by not having a PhD at PARC, you get to help other people do their research. And I, I believe maybe someday I could do my own. So that was
Okay.
yeah.
And so from there you went to get your PhD, right?
That was my dream. Yeah.
Yeah.
What happened was one day I was interviewing at IBM, and I thought the place was kind of dusty. And
This was Almaden?
no, this was T.J. Watson. The building is
okay.
literally gray. The offices are gray. They're beautiful. I mean, Cernan built this great, beautiful building where no one has a window, and this vice president, a wonderful man, Abe Pellad, who ran the research division, computer science research division, brought me into his office, and it was like in the middle of this interview, suddenly I'm in this fancy office. And he says, Ted, your ideas, they're more interesting than other ideas. Why don't you come do them? And I mean, there's nothing that can captivate a person. I mean, that was quite a flirtation thing to say. But as soon as I came, they tried to get me to work on program development environments, because that's what everyone was making, Suns and things like that. But I said, no, you told me I could do this. So I made my adaptive help system, which turned into my PhD. And,
Okay.
Yeah.
And overall you stayed 14 years. at
Yeah,
IBM.
I should have stayed longer. IBM was fantastic. What was amazing about that research center is just the depth. I mean, the guy next to me, in the office next to me, was working on cosmic rays and how they affect memories. This is in 85, sorry. But really the place was extreme. The mathematicians, I mean, were incredible, and I was, there was a lot of mundane crap going on, and very, 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 in fact, almost nothing went to market from the research division. And, it's interesting because I think that, and at the time when I went there, forgive me, I thought, oh, IBM, what a crappy place. They use, EBCDIC instead of Query just to be weird. They don't use SNA instead of TCP/IP to try to take over the world. But what I discovered was actually the place was quite flexible, and it was changing. And so at first I just said, I had a friend that wanted to do something new. He was a mathematician that hadn't written a paper in many years. Joe Rutledge, he passed away last year. And he learned to program on the ENIAC, by the way. Fascinating guy. And he was an algebraist. And, I went and got him involved with this pointing device idea of mine. And I thought, oh, this is a 6-week project. It'll kind of, be a diversion for him and me and keep me from going crazy while I write my thesis. No. It was 8 years. And what really was fascinating was the way that the organization actually wants, or at least then, wanted to embrace invention and innovation. And, it was a slow road. I mean, they have this 1-year review, scary, and then, do you get to be an RSM when you don't have a PhD? And then, and do you get to be a manager? And, it was very slow, corporate kind of feeling. But my goal was that my mom hated my dad changing jobs. My dad changed jobs for his day very often, every 5 to 7 years, which today is nothing. And I wanted to show people that I wasn't just a flake. So I wanted to stay there and accomplish something. And anyway, there's a lot to that story.
Seems you did.
I did. And I also want to say that the decision to go to there instead of Apple, in fact, leaving my girlfriend, was because Apple had a lot of people like me, people that that wanted to improve graphical user interface and make think about graphic design, think about better user interface, and IBM seemed like a desert. And I thought, if I made a difference and I came from IBM, people would know it was me, and also, and I'd matter, and this is something I like to think about, is I would much rather do something harder that would matter, that would be something that I could only do or wouldn't have happened without me, or may not have happened without me, than I would ever want to do the things that are easy, that make sense. So that's been I don't know. I think it's actually it has a chokehold on me, doing things that are not keeping on doing the things that I'm known for, not always doing the things that are easiest to get known by. So anyway, that was my idea, was to go to IBM and do something unusual.
And I guess you did. You rose to fellow eventually.
Yeah. So it's funny. In fact, one of the funniest things is John Seeley Brown himself, amazing guy. He was, the boss at PARC. He came to me as I was leaving, and now my belongings are actually in a truck going across the country. And he says, "Ted, why don't you stay and do great things here?" And I said, "Well, if I made a better pointing device," because I was already thinking about this, "and it was used by IBM, it would be used by millions of people. And you guys, I'm not so sure." I actually said that. I didn't believe it at the time, but it turned out to be true.
Yeah. Wow.
That was 85. Yeah.
Okay.
85, yeah.
So Apple already had the Mac at that point, and
that's right, they did. And in fact, we had the most amazing computing facilities at PARC. We had the Xerox Dorado, and it had a Macintosh to boot it up. And one funny aside is when I went to IBM, they said, "You can buy any computer you want." So I said, "I want a Xerox Dorado." And the Xerox salesperson said, no, Dorado's not made by us, it's made by Univac." Well, they're wrong. And finally, after weeks of trying to get them to sell me one, I called up Danny Bobrow, died this spring, and I said, "I want to buy the Dorado, and I can't get anybody to sell it to me." Well, then they got somebody on it, and after 3 months of paperwork, the vice president called me up and said, "Ted, would it be all right to just settle for a Lisp machine?" So Xerox's paperwork was worse than IBM. So that's a sad story. So I bought a Lisp machine. It was great, but it wasn't as good as the Interlisp D with loops that Bobrow and others made, Stefik, was the most productive programming development environment that I've ever had my chance to use, by far.
Really?
Yeah, much better than Smalltalk. Anyway, we could talk about this, but it's something I really was honored to be able to work for the people that worked on it, and I guess I also bring it up because it's maybe a month ago, Danny, who was so good at such an amazing guy, that designed a lot of that, passed. Yeah.
Okay. Okay, so at IBM, did you start out with the TrackPoint?
No. In fact, I wrote it down on the things that I wasn't going to work on because I invented it somewhere else. And indeed, there was a patent which you didn't find. Before I went to IBM, I patented it.
Oh.
The idea of a pointing device in a keyboard. And it's interesting.
On your own?
On my own.
On
my own.
Not associated with PARC or anybody?
No. And what happened was that I started working on my intelligent user interface work, and that went along. It was a lot of, hard programming. I made a system that taught Lisp and also taught HTML. We called it SGML back then. Very, very interesting. I remember my mentor, a man named Ashok Chandra, who really is responsible for me doing so well at IBM. He was never my manager. He was always in the wings, being interested in my work. Anyway, I remember I went to him trying to test out my help system, which was, on a Lisp listener, and he says, "Ted, the help you want, I want you to see, I was comparing the help on a Lisp listener to mine, which was a graphical user interface that decided when to put what kind of help where, and put the stuff that's most important to you near you, and put the stuff that's about why stuff works as the headline when you never thought about it before, and then come in with examples, and then the generalization of examples is syntax and different levels. And so I had this AI system that did this stuff, and he said, you know, if you really want to test this thing, you can't test if your help's better, you can't test whether the graphical user interface is better. So he made me, this is not a user interface guy, but he made me run my experiment. So I compared the same help on the same graphical user interface compared to the one with the AI system that decided when to put it up without you being asked for it. And back then, the idea that things coming up without you being asked for them was terrifying, and everybody hated that stuff. That, you know, that anything that customized itself or was surprising, of course, is difficult to deal with. So, the real big excitement was that people using the same help liked the help system better. They liked lists better. They liked the the user interface better, but also they got 5 times more exercises completed. So I say that this coach, adaptive help system that I did in my Ph.D. was 92, was the first demonstrated performance improvement for AI helping user interface. And there began my lifelong battle with Ben Schneiderman, who believed in direct manipulation. But anyway, that was real exciting. And what kept me sane while I was doing that really, really, really hard thing, I thought, was working with Joe Rutledge on this pointing device on the side. And that was, you know, when we first started working on it, I found a microscope that was broken in the hallway, and I fixed its front surface mirrors so we could use it, and found a little cubby hole and by the time we were done, you know, the same Ashok Chandra said, well, you know, you say it works great, but why don't you make 100? And as, you know, we're getting into it too much here about this, but as would happen, after I'd make 3, I'd learn something and make the next 3 better. And so we had made 100 and had lots of bad and good user experiences. But the most exciting thing, again, with Ashok Chandra at my side, I went to Japan, where we'd been comparing this pointing device compared to a trackball and a pad.
Comparing in terms of
how fast you could make a selection.
Or
yeah, user tests.
Okay.
So how fast could you make a selection? So me and Joe Rutledge, we wrote these experiments, and we let people try out running experiments. And there are people in Austin, Texas. There are people in Yamato, Japan. There are people in Boca Raton, Florida, and there was us.
so it's IBM people.
Yeah, IBM people
Okay.
only, yes. Very. And quite frankly, they found different things. And Ashok had the foresight to point out that, look, you know, if we put them all on one slide, it'll help make the comparison great. And that comparison was showing that it took 30 to 45 seconds to get as good as a pad, and then so when you first started off with a pad or a trackball, they were faster, and but 35 seconds later they weren't. And then 3 minutes later, you actually could do text editing faster, with a little bit of 3 minutes of exposure to this thing, faster than a mouse, and as fast as a mouse. And after 45 minutes, you could actually do it faster than a mouse. And so that was really big deal. And how we made it, we can talk about that another time. But really the big deal of getting it into product was showing that these people all over the world working on showing that it wasn't consistent, by Ashok's point of view, had shown that there's a learning curve. And this learning curve was so short, but the product manager said to me, and to the guy that had done the study in Yamato, who wanted to, he was in bed with the people that made trackballs, he said, you guys have to get rid of the learning curve. You have to make it as fast as, you know, the trackpad or ball right away. And so my job was to help the guy in Yamato contribute, so he'd feel like he was part of it. That's what I thought. And indeed, he had a very, very good idea, which was that if it moved a little bit, that you would feel that. And indeed, you got a 15% performance improvement if the rubber top moved. And that's how...
feedback, I guess.
Yeah,
right?
proprioceptive feedback. Yeah, we have these Persinian and Marcusian cells in our fingers that measure lateral movement. By the way, once you get to learn it, well, that doesn't matter. So it's kind of like throwing a ball, I think, you know. But for the beginning, that made a huge difference. And it took us a week. I made probably 50 different tops. I went to every ping pong rubber store and every Tokyo Hands was where I bought a lot of my materials, and I kept making them and having him test them. And it was really great fun. That was a very special week.
Oh, only the top matters, I guess, right? It doesn't stick much up from the keys.
Yeah, that's
and
another.
So it's only the top that you have. You don't grab it.
Yeah. So what's interesting is I didn't bring one with me, but at the beginning we had a metal rod, and you could grab it, but I wanted you to put your finger on top of it, and we thought that the connection between that rod and your finger, it was a cup-shaped thing that had like sharp edges, so it'd grab your finger. We thought that was really important, and it was stiff was really important. And of course, we found out that that's not true. The stiffness, it actually hurts your finger. And a wonderful man named Naito, Orisama Naito. And Orisama Naito is the product manager responsible for ThinkPad being a success, by the way. This is the most incredibly flexible, brilliant, collaborative guy ever. Anyway, he very hard ass, but he I remember he pointed with this thing and he showed me his finger. He said, "This look at this. You made a dent in my finger." And so, getting rid of those two problems was was the goal of that week. And we thought that, you know, and it turns out gushing in and grabbing the finger was a very good idea. And yeah, the rubber, you know, 55 durometer rubber was a good thing. And I can go on about this. The other thing that's really interesting is that the first ones, if you look at a keyboard, we first started by, does anyone have a stylus I can point with? Do you have a pen? Anyone?
I have a pen.
Can I borrow that, please? There we go. So the first place we put it was between the G and the H. And that's a very, I thought it was good because the fingers from the left hand go over to the G and the right hand go over to the H. Mm-hmm. But in fact, that's where your finger's fattest, right, in the middle. And it took me those 100 keyboards to realize that moving it down below the G and the H is where your finger's not fattest, and it's between the fingers. I was terrified. To this day, I'm shocked that people don't have trouble running into it when they type, but we worked hard at that. And there's lots of other places that I found in the keyboard where you don't run into it. For example, I might have it with me, but anyway, we tried putting things between the space bar and the keys. Your thumb comes up to the space bar, your fingers go down to the keys. They never mix. So this is kind of a microcosm of, I build mechanical things as well as conceptual things, and I just think that understanding how to work with people is really the center of making technology. I say technology is something like listening, where techniques are something like voice reco. So listening, we have to get the feedback, we have to understand the other person, we have to work with them. And I've always been excited about people and making things to help people. And so what you'll find in all the things I build is a love of solving problems that help people do things. So is it user interface? Is it technology? It's about solving problems that help people.
How many hours of tests do you think you ran? User tests of
TrackPoint?
Of the TrackPoint. Or, yeah.
So what's really interesting was what we did differently than the 100 years of people trying to make rate control devices did before us. So what we did differently in our tests is that we made an interactive suite where you would make a transfer function. That's how hard you pressed, how fast it goes. And then you'd run through a little maze. We had a little racetrack. And we'd run through that little racetrack and see how fast you went. And just Joe Rutledge and me, less than 2 weeks, we discovered one day that we made a version of the TrackPoint that was so painful to use that you couldn't do it very long, but you're 25% faster than any of the reported literature on making selections for a rate control device. And it's really interesting because in the 1890s, people were trying to use rate control devices to an other, gas pedal, trying to understand, and they always reported overshoot. You go too far and you come back. And that was what we'd gotten rid of, was you didn't overshoot with this one that was so painful. And I thought, oh my God, it's all about dynamic range. We're pressing so hard, we got lots more dynamic range. And what I discovered was we ran another experiment where we had a circle, and we hold the cursor inside the circle, and then we make the circle smaller and see if you can still hold it inside. And we found out that actually, in our experiments, Kai didn't accept our paper. I'm sorry, it's not published. This might be the publication. No, there's some talks. That you only have 4 or 5 bits of control for force, and that repeatable force, and that at about 200 to 300 grams, it goes away. In other words, you don't get more dynamic range by pressing harder. So then I was really curious. Why was it that when I pressed really hard, I could go faster? I mean, I could make selections faster. And what we discovered, or what we believed, sort of running hypothesis, is that if you go too fast, you were losing track of it with your eye. So we made a funny transfer function that never let you go faster than your eyes could track, and we kept and you could do it with pressing softly. Voila, beautiful pointing device that everyone hated. So what I think had happened to everybody else's experiments is they did experiments where they made something that felt good, and then they passed it over the wall to somebody that tested it. And what we did is we made things that tested well by an interactive process. That suite, Joy Test is the name of the program, we would change the transfer function and try a new one in 2 minutes. Okay, you take 30 seconds to try it, you make another one, try it again. So that iterative cycle that went so quickly allowed us to discover this thing. By the way, we didn't discover why people hated it for another 6 months. The reason what we did to get rid of the hating was we made so when you pressed hard, it went really fast. And that we didn't understand why people wanted to go really fast, because we knew it didn't make selections well. So we made it so you'd press and you could never go faster than your eyes could track until you pressed really hard, and then it would zoom. And later on, we found out that it was because our experiment was all about making selections, fit slot selections on a screen, that what people like going fast for was to change windows. So context switching is really important to people. Zoom, I go over to another window, do my text editing. Zoom, I go over to another window, do my email. And that
does not require precision, because
that's right.
The window is large.
That's right. And there's a whole much more to say about this, but I'm still trying to answer your question about how much experiments. The answer is thousands of hours, probably. Now, the parts that mattered, tens of hours. And yes, there was refinements and improvements. I mean, for example, we came up with this idea that if you were going in one direction, this did matter. I mean, and so there's thousands of hours. Rob Barrett made this idea. Took my bad idea and improved it. So I had this idea: if you went in one direction, we should keep going in that direction, right? Well, that's called hysteresis. It's a bad idea. But we came up with this really cool idea called negative inertia. So when you start slowing down or you start speeding up, we amplify that. So it's kind of like ABS brakes and also, letting the other direction, we can be like a 2-motor Tesla when we start up. But we have these other limitations, these limitations about how fast can a person track something. All these things combine, and that last experiment was 2 or 3 years after product announcement. So we kept improving it, running experiments, coming up with new ideas. I've got a list of ideas, about 15 long, of things I would like to do if Lenovo would let me, please, improve the TrackPoint. And so there are still experiments to be done. And there's still things we don't know about input selection. And that pointing device we tried so many things that never got to product. For example, I made an adaptive TrackPoint that actually, for some 19-year-olds, the plateau of eye tracking speed.
I was just going to ask you, isn't there an individual difference about how fast you can track?
So in my experiments in general, I have found that individual differences exist and are in the noise compared to getting the big picture. In this case, I believe that Dan Kellum could have improved his pointing speed from 0.9 seconds, which was his all-time great, to 0.8. That's quite well. That's more than
more than 10%.
Yeah, that's more than 10% with a higher plateau. And furthermore, for single pixel selection like painting, we have a special algorithm to make that work, which came from my circle experiment I was telling you about. And again, for Dan Kellum's, for the really good toy joystick kids, I think we have other ideas of what we could do for them. And then if you want to do, anybody that's watching this, let's go make better pointing devices. For text selection, we used to make it work for text selection well, and then the very famous Richard Sapper, who designed ThinkPads and also many other wonderful things, he said, I can't draw a circle, so we made it so you can draw a circle. Very important thing to be able to do with a but we compromised. And there's no reason why we can't do things great for text, do things great for circles, do things great for spreadsheets. If
you know what you're doing, you mean?
Yeah. If I know what I'm doing as the designer, I can put those into the driver, but we were not allowed to.
But the driver would know. Now I'm doing text editing, right?
Yes.
And now I'm drawing
Yes.
circles. I mean, I want to draw.
Yes.
Okay.
And in fact, trackpads do have different algorithms depending on what you're doing somewhat. But we developed a tremendous library of exciting goals of this sort that we never got to implement. And those experiments got done too. So I had a team, Barton Smith, Joe Rutledge, and a few other people working continuously on improving the pointing device. By the way, the biggest things that I got into product were reducing its price. And I don't know, you probably didn't see it, but I have patents on Cermet strain gauges and different.
Did see those, yes.
It turns out the biggest innovation that made the biggest difference to sales was one day a guy at Philips Corporation called me up and said, you know, you're buying all these processors. You're buying a lot of these processors from us. What can we do to get more of them from you? And I said, look, you know, half the cost is this damn A to D converter, and only half of it's you. I can't give you more money unless we get rid of the 16-bit A to D converter. He said, well, but there's only space for 8 bits. I said, yes, I knew that. But I said, you know, I only need 8 bits of it fast. What if we had a capacitor and we just had a floating thing? And he says, that's a great idea. And I said, all right. So a patent came out of that, and that was my idea. And what was shocking is out of that phone conversation came a collaboration between IBM and Philips. They actually built into their chips that algorithm I just described, the external capacitor, and you know it basically doubled the amount of. It made a product for them that was that no one could touch, and they ran on that for several years. They made a lot of money. They actually made a full-page advertisement with a picture of me and my friend Joe Rutledge in Wired magazine on celebration of our mutual work together, and it was an amazing. That was one of the best moments of ever, you know. It's great.
Great.
But I mean, that's a weird thing. How do you end up designing an algorithm, or you know, changing the design of an analog to digital converter when you think you're a user interface designer? Well, I realized all of a sudden if I did that, I could make an impact on this stuff mattering. And if you look, I don't know if we have time for it, but there are probably a dozen stories where things that I made an impact because I paid attention to a way it was not going to succeed. I'll leave you with one. Okay, so there's a bisection sort that happens to auto-calibrate the strain gauges when you start up this pointing device, and that is kind of, you know, there's the hardware has to change, you know, when you change, and when it's starting up, and what happened is they put, we told them not to, they put a big capacitor that had longer hysteresis than the settling time of that sort. So that means that it would be still settling when the search was deciding not to go above 128, and you know, and so I was wearing a suit. It was Madison Avenue, 44th story. It's the opening day. We're going to start delivering these pointing devices to customers, and I hadn't had my hands on a product yet. And I'm standing there, and everyone's trying to like schmooze, and I go over and I start playing with them, and a third of them went fast to the left and not so fast to the right. So I quickly took them off the stand, and I found some that did work. Some of them did. And it just had to do with where that settling time happened in the calibration of that particular post. And, you know, no one in the world knew, except for me and Joe Rutledge. When I got back, you know, got a telephone in my hands, and I called him up, and we talked about, you know, how we were going to fix this. And, you know, we had the short term and the long term, and that's how a lot of these things, you know, things that are subtle, sometimes solving them is all, you know, I could tell you stories that went on for years. While the product was being sold, there were big problems being solved that kept it from not failing completely. So.
Okay, I think that's
enough of that.
That's a great story about TrackPoint. Now you also at one point showed me a lot of other stuff you did around the keyboard.
Oh yeah.
Like mouse buttons, because your TrackPoint, of course, is just it, and typically for cursor control, you also want to say, now I'm here, right?
Yeah. So one of the interesting things about this pointing device is that your hand is on this. And so for years, I don't have it with me, I was fighting to get this keyboard pushed back so your hand would be resting on a wrist rest. Because if it isn't, it's in the air or uncomfortably on the desk below, and we could get a huge improvement by putting a wrist rest on. And the coup de grace, my very favorite one, when I was trying hard to make it, I made a wrist rest that fit between all the keys and was 0.5 millimeter thick of plastic, and the structure was the waffly shape of the keys, and then it snapped on the front of this, on this ridge, and clipped on. And instead, what they did, of course, is well, I don't have one. This you can see that there's space in front of this pointing device that was the wrist rest. And so we ended up, and now all computers have wrist rests, all laptops pretty much, or are thin. The other thing that's interesting about these buttons is this blue button is literally a way of turning that from being a pointing device into a scrolling device. And I did a whole lot of experiments on 2 pointing devices. And why 2 pointing devices? Well, 2 pointing devices because you have 2 hands. And an artist will often move things in place and work on them, hand things from a non-dominant hand to the dominant hand. We wrote lots of papers about 6 degrees of freedom with 2 pointing devices being great. But what we got into the product in the end was that third button. That third blue button allows it to be the other pointing device. And lots more could be done with that, you know. Lenovo, please help me. But the other thing that was interesting is these little triangles you see on there. Those triangles were me showing the product people, we finally put these dots on, that if you don't differentiate the buttons well enough, people make mistakes about which ones they press on. Another thing that was fascinating was, and I don't have one with me, is the first buttons were too stiff. And if they're too stiff, it really wastes time and you degrade your performance gigantically. And Dell still makes this mistake to this day, and they've been told a billion times. I think they don't want people to use their pointing sticks. But this button not being really difficult to press was a big damn deal in performance. Then there's one funny.
You didn't accidentally press it if it's easy.
This is all yeah. This, by the way, the keystroke, 60 grams. The early mice, 225 grams. So the car buttons in a car, 225 grams. So you know, it's nice to get a good feedback. Don't accidentally touch it in a car. But when you are on a keyboard and one of the buttons is 4 times as difficult to press as the others, it's not that it's not gonna, you're gonna just make a mistake.
Right.
And this one here was my first strange innovation for a button. See that? I push it and it locks it on, and that, believe it or not, there's a stupid patent on it. It's for people that have, that are using a mouth stick or something, so they can go into drag mode and wiggle it and then go back and turn off drag mode. But IBM was very good about disabilities, and I've found throughout my career that often a lot of my favorite ways of getting subversive, interesting ideas in is to see how they help people with disabilities. And almost always, things that help people with disabilities, if done right, can actually help lots of people. This particular one, it got people to focus on the buttons. And it got me to have some control over other aspects of the button's size, and I just told you all those reasons that the buttons matter a whole lot. Like, I mean, like a lot, like as much as those algorithms. The button's pressure level can matter that much.
And from the beginning, the buttons were below the spacebar. I guess they have to be,
Yes,
right?
well, the first thing I made was pressing on a key.
Oh, on
a key itself.
any
So
key? Or?
the J key.
Okay.
And we made, and then you press on that, and you'd use, and when you pressed on that and made selection, then you'd use the keyboard to make as the buttons, and it was really lovely and very elegant and hard to teach, and people would get confused. And you know, it was better to make a separate pointing device, I think. Now I could go back and maybe make that one better too, but anyway, that's yeah, for me a very interesting point. Is yeah, the buttons below turned out to be a good idea. The first thing I ever made, well, I put a joystick in the thumb position when I was in 1984, and that could work. But what's interesting that I found was the trackball being in that place in the Macintosh 160, 165, 170. Those trackballs, if you used your thumb, you didn't lose the time of leaving the keyboard to go to the pointing device. That I was my biggest goal. And in fact, the thumb has more representation on your like, you know, precentral gyri than anything on your body but your tongue. And so it's not a bad thing to think of it as a pointing device. However, people don't do that. And I went into stores and I would videotape or watch, and with that Apple, everyone would take their hand off of the keyboard and go down and use the trackball. So a pointing device in the thumb position could be a good idea, but a little harder to teach. And as I know, a large number of people have track points in their keyboard, and with trackpads, they're used to trackpads for a long story that I can whine about. But they don't bother to learn a new thing. And I think that people are busy, and they have their goals, and they are going to use the thing that they're used to if they can.
And it's just a tool. You don't want to.
It's more than a tool. It's a religion.
Right.
Yeah.
Okay. Anything more you want to say about pointing devices? Or
Oh, I'm going to just say that really, you know, you were asking me what's the consistency about TED, and it's invention for people. And so I'm going to say, tell a little story about pointing devices that took me in a different excursion just for fun. So the guy that ran all of the PC company at IBM, a guy named Jim Canavino, very interesting guy. He said, Ted, you know, you got rid of this big gangly wire and this thing that, you know, bugs me in my laptop, but I still have this I don't have one that's ugly enough. I still have this big gangly wire and a thing. And so this is actually one that's part of the solution. So the wire, if you think about it, the wires that we gave out were those big heavy wires that, you know, because they have to plug into that, to plug into this kind of a socket, they have to be able to, you know, run, you know, a PC, you know, RT. I mean, a, you know, 1500 watt thing. So you have these big ass wires, and they were like bigger than the power supply. So I wanted to get rid of that wire. And my first idea of how to get rid of that wire was to invent a new kind of a power supply that would fit in the cord. And that was this. This is, I have a patented transformer. The first,
I saw that patent.
yeah. This one is really crazy because my first idea of how to do this was patented in 1947, which was to make a core that was the length of the cord. It turns out it's, you know, efficiencies are in the 0.1%, but by making the cores small, the mu goes, the magnetic resistance goes up with the square of the length. This is actually quite efficient transformer.
Okay, I was going to ask, where's the iron?
The iron is these little bands.
Okay.
This is it's called orthanol D. It's 50% tin and a soft iron, and so this is really exciting. But I had another idea, which was, and there's a video about this. This is kind of fun to watch. Which was, I thought that if I just used the battery as the capacitor in the computer, and just snipped off part of the raising part and the lowering part of the sine wave, I could just dump some charge into this battery, and I'd use two batteries. One would be offline, so we could have the separation, and we made that power supply. So the whole power supply had no capacitors, no inductors, and just a really fast switch. Mm-hmm. And it's funny because I told this idea to this vice president, and he said, make this for me. And I was so busy on working on my Ph.D. and on the pointing device going to market that it took the head of IBM Research, amazing, just to give you an idea of the quality of people that were there at that time. Jim McGrady, he's still with us, was the most extraordinary general manager of 3,000 people I've ever known. He calls me up and he says, Ted, what about this idea you had? I heard from Canavino you had this idea about how to make a better power supply. I said, well, you know, I'm going to snip off these things. I'm going to use a triac. He says, Ted, a triac won't do that. You're going to have to reform the silicon in a different way. The way I design it. And he just dives right into designing this chip for me. So that's kind of an amazing manager. But anyway, so I was on the hook, and I made that power supply. It had a power factor problem, snipping off things like that. Probably be illegal to use today. My team wasn't so excited about it. We tried 5 different things. We tried find some better, smaller power supply technology than this. I found some very small ones. They used that. I tried get rid of the strain relief. This is a wild kind of strain relief that happens to be the MC core. That actually did go to product in this one. The cable management, that was also my idea, went into this product. I had this idea, which Apple used part of, which I'm not sure if we patented it, we may have, which is be able to plug in the cord that way, or this way, or this way, and by doing that, you end up, doing a much better job of plugging it in anywhere. And unfortunately for me, at the same time I showed the product manager Naito, not Naito. Naito was there too. Anyway, that I showed them this, and I said, and this one will twist. And we went to market with this, and why they picked this? They picked this because it's no change to the price, right? They don't have to design molds to do this. They don't have to go and become a power supply company that makes my high power factor thing. They don't have to become a transformer company that makes this, right? All they have to do is buy a short cord, and it basically makes the power supply half the size. And then by doing this cable management, they get rid of a whole nother almost third of the size. And by making this funky strain relief approach, they get rid of another bit of it. They made this thing big because they wanted to use this for different kinds of computers, so it made it more flexible. And so, for no money at all, they solved this problem that this vice president talked about. And I was furious because while I had invented all this breadth of stuff, this is my style, is to how do you solve this problem electrically, ergonomically, physically, and they went with the simplest. And I got to show you the one that got away. Today there are pretty good plugs that'll plug in anywhere in the world, but this one I have a patent on, so I'm kind of proud of it. And you see all these prongs, when you pop it out, when you shake it out, they all pop out. And when you go into the wall, whichever ones don't push in from the wall become the power adapter. So this is an adaptive power adapter. You can plug it in, and this is British at this moment. And if you don't have the British ground, then it goes in, and a light on the back turns on to show you don't have a ground. Oh. If you happen to be going into into a power supply like that in Europe, so this was great. Every executive wanted one. None of them wanted to take it to market. And AMP, of all people who make connectors, they tried to license it from IBM, and that was kind of a special moment. Didn't work out because, AMP didn't, they got cold feet. But it was a lot of fun to try to do that. Yeah. So, lots of different ways to solve problems, that was supposed to be the right. If the mouse, we can get rid of the mouse, we can get rid of the other. By the way, today, still, I would be so delighted to get rid of the power supply. And anyone that wants to do it, Dell, come find me, because it's still possible to get rid of it completely.
Well, you could put it into the machine, right?
There's a good idea.
But of course, Apple kind of started this with the super thin machines, right?
Yeah, I mean, Toshiba made a notebook that had the power supply inside, and no one noticed. And that was in 1995. And since no one noticed, everyone said, oh, well, we won't do it. And I think it's just crazy because, quite frankly, I'd like the power cable to be the strap that I can use to hold my laptop too, right? And it could also have an antenna in it. And this strap could be used for other things, which we can talk about. But so, one of the funnest things for me, that power supply is an example, and I'm going to show one other example that I got a chance to put all sorts of innovation into the ThinkPad. Once you start doing it, people like that. But the favorite one that got away finally, not immediately, it was very difficult for me to get it into product, but I did, was the idea of a display that would come off and go on top of an overhead projector. So this becomes the projector. And this was really wonderful because it cost the price of a projector and was a computer, the highest quality one IBM made, and had the biggest profit margin of any computer that IBM sold. And also, what was cool about it is that you could let the sun come into the back and illuminate it, and we did. You'd sit in and you save 20% of the energy. A lot of power goes into the backlight of a computer. And so this was kind of would capture the sun, and you could use it out in a cafe in the sunshine at the beach. But we did make this for a year, and I was very, very proud of this because it shows how, again, you can solve lots of problems in lots of different ways, and often there's technology confluences. The strap, by the way, was a way of holding it onto the overhead projector, but as I'm showing you here, I used it often to type on when I didn't have a table right before I gave a talk or something like that.
So it's pretty close to your face.
No, that's only because we have a small camera thing. But I would make this thing whatever length I need to make it.
Okay.
So it's down at my waist.
Okay.
And I'm typing like I'm normally typing. So yeah. And I still miss the strap. By the way, making this strap, this particular shape took me 6 months to come up with. And I had boxes of straps that didn't work, and it was not going to go to market if the strap required any change to the computer. And so that shape makes the strap utilize the strength of the hinge that holds up the display. So this was a very proud moment for me designing that little piece of plastic.
And it simply slips in and comes out.
Slips in, you turn a lever, and it's so strong. And in the end, this thing was very simple, but it literally, it was the showstopper. It was going to stop this thing from going to market. And then the strap was so much fun. And people loved the product. It just, we stopped it because we were stopping all unusual laptops at that time. And it's a long story, but it really has to do with Naito trying to save money by using an off-brand display for this, where we would have had to give $1 million to the company that made, it was IBM, to the part of the company that made the display to make ours, and he didn't want to give that to them, and maybe I should have pushed it, but I was with him. I believed it. Why should we give these guys all this money? And so if we had of, every ThinkPad would have been a projector. And so I'm sorry. But overhead projectors are gone now, so.
That is right.
But it was really delightful because you never had a connector problem. You'd walk up, put it on the overhead projector, and it worked. And I was at so many venues where the guy before me would have an Apple and they'd try the connector and the projector wouldn't figure it out, and they'd spend all this time, and I'd just walk up and flap it on that. And then your finger's on top of the display so you could see the pointer. It's great.
Now, about straps and taking the ThinkPad along, I did read that at one point you took a bunch of network ThinkPads up on Mount Everest.
That was great fun. I was, and thank you for knowing about that. So what was interesting is we went up there, and I was asked about 3 months before the climb. I'm a mountaineer, but I did not climb Mount Everest because 3 months is not enough time to prepare.
Now this was not an IBM project.
Yes, it was.
Oh, it was an IBM.
IBM paid me to do this, which was really quite impressive to me. And I went and modified a bunch of ThinkPads to work at high altitude. And so it's hard to know what's going to matter. I put in heaters to keep the displays warm. I put in, if I wanted to, I put in dust relief for the keyboards. And here's the cool thing about working at a place like IBM. The guys that invented the disks were in the next aisle over. So I went and I sat with them and said, what do we need to do to use a ThinkPad at 20,000 feet? And they said, disk drives don't work above 5,000 unless, And we sat there, and we started drawing wings on the head so they'd fly differently and think about the different viscosity of the air. And in the end, but then I said, well, in 3 months. And they said, oh my God, we can't reinvent the disk that fast. But it turns out that we did some calculations, and there was a certain group of disk drives that if we picked them, they were really out of spec, they would work at 20,000 feet. So we went and we call up the guys in Fujisawa. IBM made their own disks, and 5 days later, I got 5 disks that were just turns out to fit. That they barely work at sea level. I don't know why they worked at sea level. They weren't supposed to, but they'd work at 20,000 feet. And so I brought all these laptops up there, and everyone else had, generators that they were running their computers off of, and their computers were all breaking. And I had these laptops that I designed that we had a little solar cell, and we had a whole network of them. Everyone else had one, barely working computer. So I was really proud of this. And then I discovered that the liquid crystal displays would get this little funny little pattern all over them. And I thought, this is really interesting. I'll show this to people when I get back. Well, when we went back, it was gone, because what it was is that when the I believe what it is the LCD was outgassing at a very low atmosphere. A little bit of gas is showing up, and when it gets compressed, it's fine again. We could still use the displays, but that's how technology was at Everest. Everything broke, and I had so much fun there, helping all sorts of teams improve their systems to get them.
So what kind of an event was that there are multiple teams with computers?
Well, this was called the Scientific Expedition to Everest. So in 1998, there was the Scientific Expedition to Everest. It turns out even other teams were starting to think about having computers up there for communicating, but we had people from Yale had brought some computers they were having troubles with, I had to fix, and people from, so a lot of these people that wrote that book, Into Thin Air, were on our team. So it was a fairly large expedition, and we had this network. Rob Poor made this network of I2C computers that went on a chest, and at the last minute we were up there, and it was all made by students from MIT, and poor Matt Lau and Maria Redding were having to debug stuff, but they had this blood oximeter on your finger, and no climber wants to wear something in their glove to measure their blood oxygen. So I put it on the sternum, and there's a photograph of me being very happy when I got that working. But that was a lot of fun, a lot of fun at Everest. Yeah.
So you said you didn't go up,
No.
but how high did you go?
Well, I will not confirm or deny that I went above base camp, where you're not supposed to go above. I climbed several mountains that were not Everest along the way. 21,000 is about as high as I ever want to go, because there's actually a tap response that now I'm old enough that probably it's gone anyway. But when you go above 22,000 feet, people seem to lose this fast tap response. So that's the only neurological thing we know of.
Really?
That's for sure lost going above that. So I've climbed 21.5 in Ecuador. I climbed.
That's with oxygen?
No.
No.
Wow. No oxygen.
Hard physical exertion without oxygen.
Yeah, it's hard. It's fun, but it's hard.
Wow.
Yeah.
Okay, so but the ThinkPad was only one of the things you worked on at IBM.
Yeah, IBM. Well, I worked on a lot of wearables. So this was a wallet that I wanted so badly to make. That was going to be a 4-ounce telephone that also had a scanner in it to scan your receipts, and it had a electronic what do you call it, credit card that would become any kind of credit card you wanted. We've gotten a little bit beyond that finally, and it had a way to get on the World Wide Web on it. And
With
this
the
was,
display?
What?
Display?
Yeah, display. So I made mock-ups of this, and it's interesting because even after I left MIT, I went to IBM, and they were talking about making an electronic wallet, and I said, I'd like to make it, and yeah, we didn't do it, let's just say, but yeah, there's, no, not all the parts are here, but yeah, anyway, this was a lot of fun. Oh yeah, here's how I mocked up different kinds of user interfaces. Paper prototyping is always a useful way of trying out how things would look. People loved it. Lou Gerstner, the CEO, wanted me to do this, and what's interesting about companies is that even the CEO can't make some kinds of decisions. He started a task force on the topic, but in the end the watch went out. I was part of that task force, and we decided to make a watch. And smartwatches are still a big, exciting idea. We had a Linux watch in 97, 98 with, silicon on chip and everything.
So this was before that?
Oh yeah.
Okay. So probably was a bit short on computing power at that time.
No,
right?
I think the problem was that I just lost a fight. And I think that the smart wallet was a fabulous idea. One way it came out during that time is we actually, my group made, this is a boarding pass for an airline that's now actually defunct in New Zealand, that we made the whole operating system for it, and we had this idea that if you were a fancy traveler and you're walking by, they changed the gate, and maybe they'd give you a free Starbucks coffee because you missed your gate. And we actually deployed it in New Zealand. Now, of course, everybody uses electronic boarding passes.
And now it's in your phone.
That's right. That's
Which
right. It doesn't look so
everybody
different,
has.
does it?
It's not a special purpose.
No, that's right. But we tried. We literally deployed this to high net worth customers of this airline in '97. That was kind of one of the things that we were going to do with that. And, yeah.
Okay, and even at IBM, though, you worked on user interface in terms of like gaze tracking and things like the compute on just knowing what you want, right?
No, that's right. Intention is what I care about, right? And my group made the Blue Eyes structured eye approach to eye tracking that Toby uses, and Myron Flickner headed up a lot of that. And one of the most exciting two projects that I was really proud of during that time frame around that was, I said, is that eye tracking is not any good for text editing. So and I would play
too high resolution. Right?
It's worse than that. It's that you can't stand focusing on something besides the tiger that's going to come after you. So when you're doing it, your eye's fiddling around, first of all, because there's dither and there's tremor and there's slow and fast pursuit and ballistic movements. But that's not the big problem. The problem is you don't like doing it, and people can, even when they focus on it, they can do like 4 to 16 characters a minute. So what I said is, let's use the eye for what it's good for. And what the eye likes to do is say, that's cool. And so we put a strip of news going across the bottom of your screen. By the way, we had AI to decide what to put there, and we can talk about that. But if it attracted your attention, you could read it, and we could tell if you were really interested in it in 1/3 of a second. So you could read it, no problem. If you stared at it for 1/3 of a second, up pops the article. Well, it takes almost a second to mouse select. So this is faster than you can possibly select with a mouse. So very exciting, got me in ABC Nightline. Nobody used it, but it was a great idea. But what also we did, a related idea, Schumann's eye worked on this, was taking the idea that what is your eye doing is a good place to let your mouse do the accurate work. And so we found this thing called magic pointing, where when you looked over there, the mouse would be there when you wanted to work with it. and that saved 20-30% of the time of making mouse selections. So very exciting. I wanted to do lots more with eye tracking and cameras in the computers. Back then I was trying to get an origami camera to fit into the laptop. But the first camera on a laptop may have been the IBM's. I was putting them above a snap-on camera you may have seen in the late 90s. That was my design. And I think cameras are tremendously exciting. When I went off to MIT, I continued working on these things. I used a camera in the bed to notice whether you'd woken up or gone to sleep, or whether you're nervous, change the radio station, if you're focusing on a radio on the screen or a TV, if you're focusing on something, bring in more stuff like that. So we use, gaze, eyes closed, eyes open, dwell time, blink, wink, to decide what to do instead of target practice. And if you want to know how good that is, this was using the IBM camera, by the way. We've all, I don't know if you've tried it, but if you try using these eye tracking demos to control things, you can get away with it. It's terrible. This one, people would walk into my lab, lay down on my bed, and gaze up at the ceiling and do this. Now, why did I pick a bed as my first place to do this back in the late 90s? Was that holding your head stable was one of the big problems of eye tracking. And so what I'm always looking for, again, is the confluence of where would this be useful, where we wouldn't have to change what we do. And so that bed demo, it lasted for a decade. It got on Good Morning America. It got on lots of great shows. But that was great, and that's really thinking about the eye. In fact, if I can digress one moment, one of the first things I did when I went to MIT was I made this, and this is a one photodiode, no camera, one photodiode eye tracker. So all it does, it looks at how bright your iris and your pupil are, and it can tell if it's moving around because of the pattern of motion. It can tell when it's closed because it's dark. It can count blinks and winks. And so with one microprocessor that's like $1, I was able to do almost everything that I found useful about eye tracking at IBM. And so this had infrared, it's called IR. See, there's the I and here's the R. Infrared to look out at, is there something out there that I'm looking at? So the beacon is something like 18 degrees, and if I looked at a dog and started staring at it, as I did on Good Morning America, it starts barking. If I look at somebody that's attractive to me, then they will get my business card if I'm staring at them. Not me get theirs. If I look at a demo I'm interested in, it'll email me the demo. And so this, I've made this to use in parties, and you could go around MIT Media Lab, and whatever demos you were interested in, it'd email you about those demos, and what other people you were interested in, it'd email them about you. And it got used by Saab to look at dwell time of people that were running fighter pilots. It got used by I had students that made it so if you started falling asleep while you were studying, it would wake you up with a buzzer. So what I'm excited about is this idea of making really, really, instead of tens of thousands of dollars, which is what eye trackers cost back then, to make something that was $10 that would solve the problems that people actually could solve naturally with an eye tracker.
Now, did this actually know where you are looking, or did it just know
yes.
You're not moving right now, you're kind of fixed?
The trick about knowing where was that it had a cone of infrared communication that is, there it is.
That is fixed to your head, I guess.
That is about that wide. So I'm looking at you, I'm looking at a laptop, I'm looking at that other person, I'm looking at this demo over here. So it could tell within that range of the semantic item you're looking at.
If that item cooperates.
Yeah, if it had one of these
Okay.
with these beacons. in it.
Okay.
Yeah,
yes.
yeah.
Okay.
Yeah. So
Yeah.
that was the idea, and so that there I am kind of trying to put together a scenario. I think scenarios are the right way to design. You think about the whole story of what will be the feedback, how will it work. So instead of trying to fight so hard, I tried so hard with at IBM to get the guys that ran the speech reco to think about feedback. To this day, I don't know if they work on feedback. Yeah, hey, yes. All that stuff makes understanding a person much easier, but we don't really think always about the whole scenario. We think about the techniques we're working on. And that's back to my technology versus techniques thing. Think about the whole problem. Be courageous enough to try building a piece of hardware instead of just writing some OpenCV software sometimes. And I made lots of other eye tracking stuff at IBM, at MIT. I mean, we had this face interface where we could attach any facial gestures to characters on a web browser, so that you could control your computer with your face. We went off to Taiwan. I ran these workshops where people used cameras to run their whole cave experience. So they'd have projectors on a wall, and it could tell how many people were dancing. It could tell and do something. It could tell whether who was looking at it. And so, when made a system for Pepsi where it could tell how many people were at the Pepsi machine and make games for 2 people to play, tell if you're paying attention, and then put up the news instead of put up turn it into a vending machine if you're looking at it as a vending machine. So I spent a lot of time thinking about lots of ways of using these things. In fact, Envision, one of my students made this wonderful system where it could tell what you were interested in on the screen and group them together. In our case, we were interested in what sponsors of the Media Lab you were interested in. We put them all together. So a lot of things you can do with eye tracking, and I think that people are trying hard to do other fancier new things, but I think that still it's still, even today, lots of people don't realize and are having trouble sometimes when they don't recognize that there are lots of things we do with our eyes that are about saying, I'm paying attention to this, I'm focusing on that, I'm doing the other, and those things are quite useful. Whereas if you don't watch out, I mean, one of the first product that came out that really no one ever complained about and worked great was Canon made an eyepiece that could tell where to do the light meter on your camera. And so that's, to do the focusing and light meter.
Okay.
Very simple little thing, right? It's not trying to say target practice, saying, in that area something's going on for this person. Well, what if I focus there? And it was delicious, and that's what you want. You want to make interfaces that have that, of course, delicious feeling too.
Okay.
Okay.
One thing that struck me as, well, unexpected, I don't want to say strange, at IBM, I found that you did a digital living room at IBM, and I thought, IBM? Living room?
Yeah. No, that was my job, is to do the unusual, and I was so much fun I was so happy and honored that they let me. Thank you, Ashok. So my first foray into that area was I had this idea that people don't read on the wall. So what would it be like to make a wall display that worked with, and I didn't bring it with you, with a tablet? And so what I would do is I'd see a book on the wall and I'd point at that book and I'd have it. Or I'd point at that spreadsheet and I'd have it. Or I'd point at my email and I'd have it. So there'd be a picture of, a bunch of mail on the shelf, and I'd grab it by pointing at it. And so I made that scenario. I made a table, this gorgeous table that at that point, to make that work, I had 5 computers in this table and a projector and all these tethered displays. Made the whole thing, and the idea was you could make any room. So your boss walks into the room and you've got a room that's all full of PERT charts and all of the, what do I call it, the all the people that work for you and their progress reports and stuff. You know, your colleague walks in, boom, it's, you know, it's the calculations and the technology and the procurement. So I made this and showed it off at the Olympics, by the way. It was a Room with a View was the name of this thing. And it got a lot of news play. It probably didn't write enough articles. But the idea was you read at kind of the distance your arms are at, and you get oriented out there. And so user interface is two things, being focused and oriented. And who wants to go over to that, you know, that old office that we used to have with all those papers and books and stuff? It's great. Go into that office, you can kind of get to know a person. Wouldn't it be great if you could have that in a hotel room too? By the way, anyone wants to make this product, let's do it. So that's what I made, and I went and it went on tour to. I got invited for a month-long demonstration called Living Room of the Future, and so I made a scenario around this thing where, you know, mom's reading the news, dad's playing Sudoku, the kids are doing their homework, and we're all sitting there together in the kitchen. What I used to say at that time, and it's not as bad as it was, that everyone went off to their office, their bedroom, to play with their computers, and they weren't getting together. And so by making this shared fancy platform, you know, the kid could have a big pile of papers all over the table while mom's making dinner, and when it's time for dinner, they're gone, right? They're virtual. And so this idea of bringing people together through shared use of a fancy device, you know, the whole wall being your organizational schema about your paper you're writing for.
So that's also a display, the wall.
Yeah, the wall's a display.
Okay.
Yeah, the wall's a display. That's the low resolution orienting one, and the high resolution one's the tablet. So you point at the low resolution one to get the stuff, and that was Room with a View, and that got on Nightline, but it almost got in the product. You know, so many people at IBM thought that was a great idea, and no one would actually make it in. And it would have been great. We would have been in the furniture business, right? Making these beautiful tables. This table, if you ever see a picture of it, it's a delta-shaped table that was designed so if you're talking to somebody in a difficult decision, you kind of across the pointy part of it. If you're cozying up, you're around the round part of the table, and if you're kind of working adjacently, it was like a delta anyways, a gorgeous table, and yeah, but. So Living Room of the Future, that went through a couple of different iterations. Another thing we tried with it was, and it would have been a great product, anybody call me up, where you walk into, you buy this thing at Best Buy, and it's a coffee table, but it's also a great speaker system. And it's also got every kind of media, you know, you can put in CDs and DVDs and cassette tapes back then, and you can, you know, pull out the keyboard and use it as a computer, and one wire, right? Because you got, instead of having this big, complicated, you know, sound system, by having these different sides to it, we could direct the sound every direction, have a high-quality sound system that's one wire, plug it in, and
display too.
Of course, it's a projector.
In the
of course.
in the table.
We project it on the wall. Okay. Our idea was a mirror, and you project on the wall. So for you know, watching movies, you watch those on the wall. So the table, again, maybe there's a keyboard, but the, you know, and you could have the tablet. But the idea, I mean, I think it's still a viable way to make it. You know, subwoofers have gotten smaller, but you know, and we pretend we can plug them all into the Wi-Fi, but you know, one wire is kind of nice.
Although now you have a lot of speakers that use Bluetooth,
yeah,
so they don't have wires anymore.
That's right, except that where do they get their power?
Yeah. Well.
They have to plug in somehow. Right.
Yeah.
And they can be charged, you know, that's right.
And they have very efficient amplifiers now. The
yeah, they still have to be charged now and then.
Yeah, right. And yeah, another last thing that struck me from your IBM time, from one of those articles, is the emotion mouse. I said, emotion mouse? You didn't bring one by any chance?
No. I did. I mean, a lot of things got played with. I mean, I made an exercise machine at IBM. I made a smart couch. If you sat down, it would recognize you and what was on your schedule and talk to you or play music. I made so many fun things. I made about 40 prototypes a year in that lab, and about 3 of them went to product. And I felt that was doing poorly. It turns out we were doing fine. But I'll show you one of my most strangest mice, though. This, at a time when I wanted, you know the scroll mouse, right? Well, we did a study and found out that if you could go any direction instead of just one direction with that mouse, and you could have different speeds by pressure, something like a TrackPoint, you'll see that there was some IBM products that went that way. But the first idea was they said, well, we can't spend any money on this. So I made this one where there is this button, which turns this mouse into a scrolling mouse. Actually, all it does is presses a piece of rubber down to keep this roller from moving, so that the motion of that rubber has to do with the flexing of that rubber inside, and that makes it into a joystick. And so, simply
rate control again.
Simply, yeah, I'm kind of rate control. And this is the adjustment for the thing. This is a prototype, but simply pressing down using the sensors that already exist, I was able to make a scrollable mouse without adding any electronics. And that is just something I was very proud of. Yes, we were measuring emotion. I think that emotion is a technique, and what to do with emotion is the interesting question. Whether I'm interested, whether I'm bored, whether I can be made interested, all of that's really the focus of the work that I've done around affective computing, Roz Picard's term. But I think that really the hard part is figuring out when to bother a person. And a lot of my best students' work was around that topic. So the most Ernesto Arroyo, for example, made something called Disruption Manager. He's my Ph.D. student at MIT. And Disruption Manager decides when to let an IM come into. So if you're typing, wait a moment. If you're browsing with your cursor, wait a moment. If the message that's coming in is different than the one that's coming next, maybe clump some together that are on the same topic. We got 30% faster at taking orders. We got better accuracy. We increased people's performance dramatically by varying the interruptions and understanding the difference, as he called it, between disruption and interruption. Interruptions when you stop what you're doing because of a disruption. Disruptions when you stop what you're doing and do something else. Interruption, something trying to get your attention. So that notification thing, again, my most recent PhD student, Rahul Rajan, did a wonderful piece of work where we watch a audio stream, and this is actually something that I am trying to take to product. We watch an audio stream, and we are able, we took all of the things that people know that they hate about conference calls, and we were able to figure out how to make people better at not taking over a meeting, better at speaking up when they should, make people more aware of who's spoken, getting rid of noises in the background. So we used some AI to recognize goals in the meeting and support those goals. So that's raising a level above an emotional response to what is the emotion about.
This is just audio or using the video as a cue?
I actually have made both, but the audio is where a lot of the papers have written about this.
So just based on audio, you will...
I can decide some way to interject some audio. So my dream was, all right, I can make human-computer interactions better, but can I make human-human communications better? And okay, let's choose a really small, communication path, which is audio. and I'm going to add noise to that. Can I add noise, that sound, to the audio and improve the communications with it? And so that's back to my AI and user interface theme, which has been throughout my career, to a paper last year, and then some prototyping since then. I've got prototypes. Anybody that wants to give me money, I've got a product for you. Yeah, and that's an example of really starting to use intention, which I think is another lay above emotion.
I would have thought you really need to see the person to know, like, when to speak.
Well, guess what? We have statistical evidence that we're able to help people collaborate better with only audio.
Okay.
And that's what I'm really proud of. I mean, it's a surprise. It's kind of that. I chose that. By the way, it was very easy to make it worse. You start putting, noise behind somebody that's speaking, and everyone's unhappy. But, very simple things like identifying a disruptive external sound, like television or a horn or something. When I could take the ownership of saying who's not on mute, we always say that, away from the person that's taking the ownership of saying that, it actually helped. So we found in our studies that when people, speaking of emotion, when people said something like, maybe you've talked too long, whatever they say, it raises the stress in the whole meeting to have to have a little bit of conflict in the meeting.
Yeah.
And so that was one of our tricks. Another example, not that we need 10, but my student who's now a full professor at UC Austin, University of Texas, Austin, Andrea Lockhart, did a piece of work for me where it wasn't even her master's thesis. That's interesting. It was just a piece of work. Anyway, she went all over taking videos and had a microphone that watched her audio reactions to the videos she was making. And we found that we could pretty reliably find her giggling about things when she was enjoying taking videos of them. And once you know that that's the thing you're supposed to do, it's also a way of tagging it. And because it's something that people naturally do, I love overlaying something people naturally do with something that's going to be a control sequence so that people can remember it better and do it easier. And I've found many, many examples throughout a lot of the work I'm talking about overlaying something. And we found in a 1 hour segment that she took, 4 times that she was really interested in what she was videotaping. So this was her emotions about her work.
And that's not too personal in terms of somebody else would have some other noise.
Well, she's the one making the video. It's her video.
Okay. Well, but that means the software that deals with it has to learn her idiosyncrasies.
Actually, we used a hidden Markov model, yes. So we did some training,
okay,
and it was on her. But that's kind of appropriate in that, not all solutions are for every purpose, but for the purpose of mom taking pictures of the kid, it's kind of right.
Yeah.
Some family video footage. Probably the professionals, like the guy behind the camera here, unfazed, He's not going to help us. You're going to have to do the editing. But I did notice you giggling just now about something you're interested in.
Yes.
So maybe your affect will help.
Yeah, maybe. Okay, so this... Two more things I want to ask about IBM. One was, you started out at T.J. Watson.
Yes.
But you're here now.
Yes.
So you split your time, or at some point you decided to come here within IBM?
There's a funny story. Ashok Chandra, my big mentor, again falls into this story. My wife was living in Seattle, and I was at that time willing to leave IBM, go be with her in Seattle. That's how I felt about getting together with this girl. And she's no, I want to live in New York with you. So she comes to New York, but I don't want to live there forever. And so, we're going to live there for 2 or 3 years. So after 2 or 3 years and getting the TrackPoint launched and getting my Ph.D. done, we're going to stay there till you get your Ph.D. and you get this other thing done. And so one October, when we just launched the TrackPoint, I said to Ashok, I said, I'm going to leave IBM to go to California. And he says, well, turns out I just took a job in Almaden. Why don't you come and start a group there? It came out that fast. And so he just made a place for me and let me build a laboratory here. And it's what I wanted to do. I wanted to be in Silicon Valley. And we started, I mean, he let me do so many fun things. Like I wanted to put IBM, if I wanted to be on the map in human-computer interaction, so I ran a workshop called New Paradigms for Using Computers that we ran every year at Almaden, so people could recognize that IBM was not just a closed, tower in the sky, but we had James Gosling gave a talk about Hot Java, a new web browser before he had the language. Before the month that Mosaic came out, Terry Winograd gave the talk, Hacking the Internet Superhighway, where he was talking about Archie and Veronica and all these old tools, ways and stuff that we had back then. So it was a really historic bunch of talks. I welcome anybody to go find those talks. I can give them as an archive to the Computer Museum. But we had, John McCarthy and a lot of the greats, a lot of the people who are making videos gave some very, very exciting talks. For example, Ed Fredkin talking about the Internet of Things in 1994. I think he coined the term actually, and it was about the stuff that happens. I mean, he was talking about how if you had an earthquake, you could have a train that would stop before the earthquake derailed it. That's what they do in Japan. So very, very prescient. By the way, that guy did sell his island to Branscombe. Fredkin did very well. He's a very interesting old AI guy. But so that was IBM Almaden was a fantastic home. It's a place where every research member has their own view out over a mountainscape without any buildings and incredible resources. It was a great place to work. A little bit of a drive.
Yeah, I visited there once for a talk.
Yeah, it's 22 miles from Palo Alto where I lived.
Okay, and the last thing was IBM went totally out of the consumer space, right? And what your focus was on people.
Yeah.
If not to say consumers, right?
Yeah.
So do you feel like you left at the right time, or?
Well, that was on my mind at the time.
Really? You saw the writing on the wall somehow?
I'm still a little sad that I left. I did continue consulting with them for many years and enjoyed that. There's always an opportunity to help people. My most recent thing that I tried to encourage them to do is to work on great program development environments for cognitive computing and systolic computing. So they've made these amazing new paradigms for programming, but how do we debug them? How do we build them? And making the user interfaces that are going to be a lot different than endless view with loops. I've always had a soft spot for working on program development tools. Tools are wonderful. I build tools, but they have people working on it. Actually, one of the guys that used to work for me, Myron Flickner, works on it. But I think that's so there's always a chance to work on things that help people. Global Services is their consulting arm. I think that they could have and could use amazing tools for their people. But it was a decision, and in fact, I remember after I'd left IBM, having a conversation. I still had contact with the CEO and the general manager of research, and I had a big argument about them selling the ThinkPad brand to Lenovo.
Right.
I was really unhappy about that, and they thought it made sense because of margins. I thought it didn't make sense because it was a very important branding statement, and people appreciated and used them, and still do. I mean, I still use a ThinkPad. By the way, a lot of the same people that worked on it at IBM are at Lenovo, continuing to work on it, yeah.
After IBM, you went to MIT,
Yes.
right? What made you leave and go to MIT?
My father had always wanted to be a professor, and he didn't end up getting his Ph.D. He had 7 kids when he was trying to get it. And he taught in a university for a little bit, but he always wanted to be a professor, and that weighed on me. In fact, that's why I turned down many of my, actually even Google. I turned down Google to go to MIT Media Lab. They were just starting, and I'd been working with Larry and Sergey, and they wanted me to come. So I always wanted to be a professor. MIT was a very big, exciting thing. And it was one of the guys said, actually Nicholas said, well, it's the 3rd time we're asking. And he was saying, basically, this is your last chance. Yeah, so, it was a life goal. Tremendous students, incredible students, incredible faculty, over 100 sponsors, all interested in innovation in different areas. I always felt that, I was more innovative than just the computer industry. So at MIT, I got to work with, I was so lucky I got to, for fun, I worked with the food industry a lot. I ran something called Counterintelligence about food of the future, kitchens of the future. I worked with the car companies. I worked with Chrysler and Ford and the Postal Service. I worked with MasterCard. I got to, here at MasterCard, I designed a physical security for a credit card that they almost produced, and they paid me to work on. And, I worked with, one of the things I'd worked on at IBM was, this was the first try at what I called eSlate. And this was a working thing. It had links, it had authoring tools for making something that was going to be cheaper than books, $100, and you'd be able to, teach kids with it. And it had a little button on it to call for help if some bully, and Denmark actually considered buying it from IBM, but I was pretty focused on the ThinkPad. So when I got to Media Lab, we started talking about it, and I'd given a lecture at as part of visiting the Media Lab long before, so I was keynote speaker at their agents symposium, and then again at their wearables symposium. And the wearables symposium, I showed him that, and Nicholas got interested. This was the wildest design approach for the one laptop per child. This handle is the cable. The cable in a laptop going between the display and the keyboard, one of the most difficult, expensive things. So I made it into a cable, so it wasn't trying to be compacted inside. It was a carrying case. But then the idea was that you could make the keyboard fold out and Velcro the display on anywhere, and this was just too confusing for everyone else. But it was a fun exploration. I made a whole bunch of different industrial design ideas for that one laptop per child, and I actually
that was during the MIT time, right?
Yeah, the MIT time, and we built the one laptop per child. I did a lot of the anyway, early work, and then later on I solved some technical problems in the keyboard. But that was, so that was one thing. There's such a untethered way that you do things at the Media Lab. What I missed about the Media Lab was what I used to say is at IBM I worked with professionals, and at MIT I worked with pre-professionals. Because if they become professionals, they leave, right?
Yes.
So that even in deciding how to, even in how to decide how to go forward with something like one laptop per child, that was really not done with the kind of support and infrastructure that you would do it at an IBM. And so, you know.
Oh, so that was an MIT project?
Oh, yeah.
I didn't know that. I thought it was some, well, I didn't know where it was.
Yeah. Well,
at the time I read about it, but...
yeah. It came out of MIT. I taught the first course on programming it, by the way, me and Henry Holtzman. But it changed. It became a second organization after a little bit, but absolutely. I mean, Michael Bove did a lot of the engineering. He's a professor there. I did. And Nicholas was, he stepped aside from his other duties to run it. Walter Bender, who was the executive director of the Media Lab, he became very central to making the software for it. Still works on it, by the way.
So it is still out there? For one laptop per child? I mean, now you can buy $100 laptops, right, for a kind of Chromebooks and so on.
Yeah.
But
even
you don't hear
then,
that. I don't hear about one laptop per child anymore.
I know. So that's you'll have to ask somebody else about that. But there's, you know, follow-on stories and software upgrade, and there's still curriculum running on it. But I think that yes, I think its time is, it's not its special time anymore. And funny, when at the beginning, I actually talked.
When was the beginning? Just to get
well, that's a question. I gave the first talk about with this in my talk at the Media Lab in 1995 or 6.
Okay.
But in 1998, me and a guy named Joe Jacobson, we ran a course called the $5 PC, which was really aspirational. and then about 2 years later, Nicholas started having these meetings about it. And they were amazing meetings. They were like, you know, I went to this first meeting, and there's Seymour Papert, Alan Kay, Marvin Minsky, Nicholas Negroponte talking about this one laptop per child. It was, I mean, well, maybe too much horsepower. Yeah, but that was so. Anyway, my transition to MIT, I built a group called Context-Aware Computing, and my goal was to demonstrate that AI could be useful in real-world, physical, and even dangerous settings. So I made lots and lots of prototypes and research platforms around these ideas, always testing for performance and usability. One of the transitional ones from IBM is, when I was at IBM, this is the shape. It's actually been stolen. I had a couple working ones, of a wearable that would have a head-mounted display. And I actually designed and built an actual platform that the companies making virtual reality could use. Cybernaut and Vio were the two companies that were going to buy them from us. And they had big, you know, money, VC funding. And what shocked me is when I said, all right, I can give you the computer platform for 1/15 the cost of what you're paying now. So they were paying about $20,000 for their laptop that they hooked up to their VR set. But you'd have to buy, between the two companies, I got to get an order for 10,000 or IBM won't make it. And they said, oh, we can't do that. And that's when I really questioned the whole, that was my first, that was, you know, again wondering about the VR world. By the way, I work as a contractor for Magic Leap now. I'm not going to talk about what they do, probably. But anyway, so my foray one of the first things I did when I got to MIT, and as you know, I kind of love bicycles, is to make a bike helmet that would be a virtual reality exploration that would be taking, as I did with the wallet, taking something that people already use, which is the helmet, and modifying it so you put on the helmet but you get something more. This one, the accelerometer turns on the running lights on the back and the front. I'm sorry I didn't bring the battery with me. When it's on your head, just feeling the motion. When you turn it to the left or to the right, the blinkers go on for turning. When you when there's a loud noise outside, there's a microphone, then it turns off the MP3. Here's the MP3 input. Turns off your book on tape that you're listening to, which I did all the time. And when you, so there's screeching wheels of a car or something. When you, when you speak softly, the Bluetooth goes to your telephone and lets you dial. And the reason for the BMX helmet is partially to make a sound stage, so you can talk. And yeah, also, if you scream, then this 130 decibel alarm covers up your obscenity. And finally, when you shake your head, like you went over a pothole, it opens up the microphone and geolocates the whatever you say about what happened. So this actually, there are two things. This is supposed to mediate communication from a person to the world, and to improve your bike ride and your bike experience. In fact, I ran many of my meetings with my students were wearing this helmet, or parts of it.
During the meeting?
Yeah, they were in the meeting. They were wherever they were, and I was on my bicycle going home.
Oh, okay.
So I'd run my meetings from my bike ride. 25. It was a 35-minute bike ride. So where did this come from? Two places. First, it came from one day I'm riding my bicycle along, and a car comes out from a parking lot that was hidden, and somebody's sitting there said, "Oh, that's the third time this week." And I said, God, why can't we record it as it happens and solve the problem for the next bicyclist, not wait for it to go to the city council and have a meeting and have 2 or 3 people get in the hospital first, and then have the sign people work on it, and then they come out of there, and they have the people plant it in the ground and bolt it on. So that was one thing. The other thing was I was so sick of this idea of excluding the world. And I wanted to have my hands on the wheel and my eyes upon the road, right? So that was kind of that. And so I, had students work on that on and off for quite a while, actually.
So you consciously restricted yourself to audio, basically.
Yep. I wanted to say, what could I do where I use just audio to communicate, because that's what's available, and improve it, right? Improve it is the goal.
And use audio in many different ways.
Like yeah. Audio and motion, head motion.
Okay,
right?
yes, yeah.
Yeah. So that's kind of a fun exploration, I think, that I did into telling that story.
Okay, and a lot of articles about you that I saw were about the kitchen of the future.
Oh yeah. So here's the talking
tell me
trivet.
about that.
Okay, you see the talking trivet's kind of burned. This was one of the first things I did there. So one question is, do we make a kitchen or a world that everything is a sensor net, everything's Internet of Things, or are they intelligent on their own? And one of my first real lessons in this was a friend of mine in the mid-90s made a smart house. Every faucet had a sensor on it, every outlet, everything. And so what would happen is, first of all, it cost him $500,000, and the cables, so many cables. But several things happened. First of all, somebody would push a button somewhere in the house, and something would happen somewhere else, because there's a computer in between, right? And there's a bug. Also, if a sensor went out, it would turn off the electricity or the gas or the lights, And this happened all the time. because when you have 1,000 sensors hand wired, things can go wrong.
Yeah.
And
That it reminds me of when I was at my son's.
this weekend.
We were messing with the Ethernet, and so at one point his wife comes, Stefan, when the Ethernet went out, when the internet went away, the Nest thermostat started to heat the house, and I can't turn it off.
This is right. So one thing that was really interesting to me is the same guy, it was integrating. I mean, if it rained, it would close the windows, it would turn off the sprinklers, completely integrated. However, when his motherboard went out once, he bought a sprinkler system for $49. So anyway, the idea is many people were playing with Internet Home Alliance, for example. They made a demo where you could turn on the stove with a PDA. Hopefully the cat's not on the stove. So I made this thing, and all this has is two sensors. I'm sorry, it's burned. It had a thermometer on the back and on the front. So if I put my hand into an oven, it could tell that the oven was very hot, and that my hand was on a pan. And if it was 475 degrees, it would say, I'll remind you to take that out in 15 minutes. Why? Because a pizza's thin, and a high temperature will convect in enough to cook it. Now, if you put something heavy in, roast, and it said this, I'll remind you to take that out in 15 minutes, it's wrong, right? And so you think about it, and you reflect, and you turn down the temperature to 275. So the point is that a little rules-based system can make these decisions. And this one, when you put it on a hot burner, it'd say fire. That's why this got all burned. Is I put it there, and fire. Everyone loved it.
Demoed it.
I demoed lots. And there's no battery in it, or I'd have it talking to us. But if you put your hand on something that was between 212 and 400 degrees, well, that's browning bread. That's anything that we cook on the outside that's going to get browned is going to be like that, right? And so this thing had a few messages. If you put a pot on top of it and it was cold, it'd say needs rewarming, because you don't really use a trivet unless something is warm, right? So this talking trivet was showing that individual things could have localized intelligence that could be helpful. We made lots of things. We made how long is this leftover dish been in the fridge? You can take a picture of what's in the fridge every time you open the door, so you always know what's in it without having to open it. And we did experiments, very interesting experiments. For example, we did one where there's a picture on the fridge of what's in it, and then we did one where the picture only comes as you're walking towards it, and that one stopped people from opening the refrigerator. So the action of coming up. And when you open the freezer, if there's snowflakes and a little noise of wind, people close the freezer much quicker. So we're playing around with these kind of things. Smart faucet that would actually, the best thing we ever did with the faucet. The smart faucet could tell if you had your hands underneath it. It'd make purple water that was warm. If you vegetables, it'd make blue water that was cold. If a pot, it'd make hot water for washing it or for whatever. Those faucets
with a camera to do image processing.
Yep. And you've seen that there are colored faucets now, watercolored. That came from our lab. All sorts of things, playing around with it. It was great fun, and several theses came out of it. And Kitchen of the Future, I don't probably have it here, but I made smart spoon and smart dish maker. Oh, here. Why have a dishwasher when you can have a dish maker? So I had a machine, and it would turn a piece of plastic into a bowl, a mug, a cup, or a dish. And so you could just program it, and so that way you don't have to have all these cupboards full of teacups that you're going to use once in your lifetime. You just make them when you need them. And the fun part was that you can see the video online if you want, but if you could put them in, and they'd turn themselves back into a piece of plastic. So it was kind of fun.
So as a matter of principle, do you prefer that everything has its own intelligence versus a networked network world where the intelligence is in the cloud?
Well, the cloud is an extreme. You know.
Or in a server. Yeah.
Yeah. Well, and that's right. And you know, it transfers security and reliability issues, right?
Yeah.
So you know, there's a funny story about Magic Leap, which is they had a storm in Florida, so we couldn't do any work in Seattle. That's how clouds can be, right?
Okay.
Yeah. So you know, reliability is a very important question, and why make things more complex than they need to be, and privacy is another concern, and standards are another concern. So, for example, LG and Samsung and Philips and Sony all made their own home network strategies, and none of them interoperated. And so when I was told, maybe this is that in Korea, when you're going to buy an apartment, you make sure it has the right kind of network for the stuff that you have.
Okay.
Yeah. So I'm not going to say one or the other. I'm going to say that there are these trade-offs and there's these dangers, and the real difficulty is, you know, in cars we have this wonderful thing with power steering, which is that when the engine turns off, there's still mechanical steering. And the question is, how do we make things that are reliable like that, where
Fail
it's
safe.
yeah, fail soft even,
Yeah.
where is it worth it to have it networked if you need it to be reliable when it's not networked? And that's kind of the question, because a Nest, they didn't bother, right?
Yeah.
You know, it's always networked, thank you, right? And you know, I think that there's some growing pains in this. Yeah. Now, there are very many exciting, like for example, one thing I worked with in the Kitchen of the Future with Merloni was they had smart appliances. In 95, they were on the market. Excuse me, 2005. 95, they started. And it was, I don't remember. I'm getting the numbers wrong. Anyway, the idea that was really cool is that the refrigerator, when it turned on, would turn off the heating element in the stove for a few seconds when it started up. So it would be balancing all these spikes. And back then, you'd get a cell phone call when the power was low for you to turn on your dryer, right? So they did all these things, and it was just expensive. And so Bosch was underselling them with you know, nobody quite knew why they needed to have this internet connected or networked things, but certainly load balancing, power load balancing, I think is a very top priority. I think a lot of we talk about all these usability things. I think that some of this stuff is just running society. So I think that, you know, this lovely business of time shifting power usage, you know, for a, you know, a hot water heater, and
Or your plug-in hybrid.
yeah, plug-in hybrid. You know, if you think about, for example, right, if you think about hot water, these tanks are full of hot water, and then you start taking off the hot water and filling with cold water, and the way it knows to turn on the flame is it gets too cold. Maybe it should start turning on its flame, you know, before it gets too cold, right? And there's other approaches you could use, but yeah.
However, currently that dumb hot water heater does not need any electricity. At least mine is not hooked up to the electric grid.
You're on gas.
Yeah, it's using gas, and it doesn't need. It would need electricity if it wanted to be smarter.
So you're saying your
Right.
thermostat is completely mechanical
In the water heater, the thermostat.
right now?
Yeah.
Yeah. It'd have to have electronics in that thermostat.
Right. If you
Which could
wanted
fail.
more smarts, you would need electronics.
I mean, if you take a look at your thermostat, yeah, it's probably just a bimetal strip. Maybe
Yeah.
it doesn't even have a thermocouple. And,
Yeah. So it's
Trade-offs.
It's fail soft, as you
Yeah,
said.
yeah.
Is it still gonna work?
Yeah. So I worked on lots of stuff. I mean, I think refrigerators are a very exciting area. I made something called living food, way that we'd probably use a third as much power for for that. Worked on, you know, display a chandelier where the whole kitchen becomes a display surface. Spent a lot of my life thinking about display surfaces, as you've noticed. But so, you know, you go to look for your contact lens on the floor, and it makes a grid. The kid kneels down on the floor. It recognizes there's a kid down there, and it puts down tic-tac-toe game. You know, your friends come over, and you put the tiles down. If it's just you, it's grass. A lot of stuff.
Cool.
We played with lots of things. Yeah.
But getting back to the context-aware computing, in general, that also would need a connected sensor grid, right?
Depends what you're using. I mean,
fused sensors.
Certainly, that talking trivet did not have was network.
I guess.
Yeah, it was not on the network. The first demo I made for this was I took a coffee cup and I put electrochromic stuff on it. So when it was hot, it would turn brown and say hot in orange letters, and when it was cold, it would turn blue and say cold. And so this is, you know, it's a tumbler or it's a mug, right? And that, no computing, but it certainly has this idea of context change. And, you know, the question is how to make these things reliable and useful, you know, and so, I mean, I had this, you know, I had the bed of the future, I had this kitchen of the future, I had the car of the future. Those are some of the domains that I worked on. I made a laboratory where any place you walked in this laboratory, it would demo you, run the demo if the demo was up, play the video if it wasn't. If you were alone, it would talk to you. If it weren't, it would notice where the pattern of people are and try to group them, and with little drawings on the floor, kind of. And if you were like the speaker, it would put the great big light on you and a podium on the floor projected, and all sorts of fun. Had so much fun.
And among other things, you worked on I saw a mail truck.
Yes.
So that kind of ties in with the car of the
That's
future.
right. Well, first of all, it ties in with one of the biggest sponsors that MIT Media Lab had, and I came up with 8 different new business models for a postal truck, and we got a couple master's theses out of this, but absolutely the cars, and there's a nice video about this thing, but you know, I mean, simple things like back then, putting cameras all the way around and making a very ergonomic way of seeing all the way around the truck, but more interesting is, you know, these trucks, they're parked in some of the most expensive property in the world. If they're parked on the street at night, they could actually be a billboard. So I made a billboard out of one, electronic billboard, before those were so available. And then one of my favorite things was that you have a printer in this truck, and when somebody wants a print job, as you're driving along, you're printing their job, and then pre-ordering. We had, before Amazon did it, we had this idea that, you know, a lot of people are going to buy Harry Potter the day that it comes out, so why not have a bunch of those on board and let the network tell the truck. That's a good use for a network, right? Yes. Tell, you know, the driver adds to the post office, the postal delivery of a house that has that has bought one 10 minutes ago, and so then they sell it for a premium, and guess what? Those trucks are running about 20% full mostly, and so you can have a lot of things like, if you know, in downtown San Francisco, you'll keep a couple of Aeron chairs in your truck because somebody's going to want to buy a new chair, right? So it kind of becomes a warehouse, and a bunch of other things. Like, turns out that postal drivers are often the first person to find out somebody's died. You know, things are not getting taken out of their mailbox, so why not make that part of their job? We played with lots of ideas. I made a clip-on for a postal vehicle that had a radar in it. We tried all sorts of different ways, but to know when one of these cars, turns out these cars on rural roads get in head-on collisions. because they're screaming in and out of these. They're going over to the post office box, dumping some stuff, coming back out onto the road, going back off. And by the way, they're really good at the four-wheel skid. They go sliding in next to this postal. Anyway, so I made this device to. So I did a lot of things with the Postal Service. They were wonderful. I mean, they have complicated, sophisticated technology, and they need help. But at that time, Bush was trying to privatize the Postal Service, and they were losing a lot of their best people, and they didn't want to try out anything innovative, and so a lot of these things got shelved.
Yeah, I was and I think they still, the government is pulling money out of the
Why
Postal
not?
Service.
Why
right?
not?
They bleed them.
Yeah.
Yeah.
Yeah. Why provide infrastructure when you can
Yeah.
reduce costs? Yeah.
I also found a mention of you taking your students from MIT to the Burning Man. Was that a research project?
Win Burleson came with me the second year I was there, I think, and we had this grand idea. It was too windy for all of it to work, but we had a weather balloon with an infrared camera, and we were going to map out where all the hot spots were in the playa at night, and project them on a dome, so you could look at this dome. And the dome had all these projectors in it. It was quite exciting, and the dome with imagery of the fires and everything became quite a magnet for activity. We brought a generator and everything. That was a lot of fun. It was also, yeah, I mean, I hadn't thought, I don't know, working with balloons and wind is impossible. But yes, we did do that. Yeah.
Too much wind.
Too much wind for it to do exactly what we wanted it to do, which was I wanted to go up above the whole Burning Man and have this imagery. We did have some imagery, but it was not as easy to get as I was hoping. Yeah. Yeah, that was great. I'd love to do more Burning Man. I have a Burning Man project. That Burning Man project took a lot of logistics. So my next Burning Man project, I figured out how I could make some very simple crate. One of the hardest things at Burning Man is, anyway, it's a wild display I want to make, but we don't have to get into it.
Well, we're here to have you talk.
Okay. Yeah.
Another topic that took, or that has accompanied you over years is the voting.
Oh, yeah.
Dealing with voting, which at the moment is, of course, very of current interest, right? About the hacking of the election and hacking of some counties' voting systems, I think the Russians managed.
So this is a complicated thing. So in 2000, Nicholas Negroponte sent around an email. I'm about to have a press conference about voting. What should we say? And I said, whenever you do something that's complicated, it's easy to make mistakes, especially if you don't do it often, and especially if it's stressful. So that's kind of the combination. That's a user statement. And as it turns out, we wrote this, he said, you're it. And so we wrote a big paper about the problems of voting in 2000. And it was a tremendous amount of work. And I've never had so many arrows in my back, by the way, as in voting technology.
Really?
Yeah, death threats. Yeah.
Oh.
Yeah. Yeah. But got to testify in subcommittees of both Senate and House. Great fun. But what's interesting is how the agencies all said that there are so many easy ways to hack an election that don't have to do with the electron records. On the other hand, people got very excited about this security issue. And what we saw in our analysis of what really happened in 2000 and 2004 and 2006 and even in 2008 was that registration errors were the #1 place that the votes were lost. 2.3 million or so in 2000.
Errors in terms
In
of
how you I register you, and I'm registering Republicans, and you register as a Democrat. Oops, I lost that one. There was a whole trunk full of registrations found in March of 2001 from the 2000 election. You don't know if you've really been registered when you fill out a form that somebody's given you. Lots of problems. Purging is another registration.
But how would you deal with that?
Oh, well, first of all, people should, in fact, for each of the following elections for the next 10 years, I, with others at times, and by myself other times, sent out a list of, I had 8 things to do for '08 and 12 things to do for 2012, but for things that could be done right at the time. First of all, if you don't get if you don't register with the actual registrar, you don't know if you've been registered. If you don't get a card back saying you're registered, you don't know if you're registered. Make sure you're registered. And people think they're registered because, well, what if you moved? Oops, you're not registered anymore. And there's a lot of things like this. So first of all, there's a lot of purging that's been done, which is if people don't live here anymore, we get rid of their names. But
how do you know?
That's a good question. If the name's John Smith, it's really hard. And there were tens of thousands incorrectly purged in 2000 and many times. So I worked on purging. I worked the second so registration's a very interesting topic. Now the really great thing is that almost all states have registration places you can go online and register. You've registered, and you get the feedback from them you've registered. So that's very different from in the past. Very much, that's the simplest way to register is directly with the government and get confirmation. The second thing was 1 million votes were lost because of polling place operations. Polling place operations are people go to the wrong polling place, the lines get long, they give you the wrong ballot, the ballot equipment has problems. There's a whole lot of very simple things to solve these problems, and we worked on that, including accessibility for people with disabilities. I could show you, I've got great lectures, I think, that show pictures of people. A lot of things are done ad hoc at the last minute. People write with Sharpies. People try to make up their own rules that are running the voting places. A lot of people were turned away for not having ID in 2000 where there was no ID law. I've even seen places where two pieces of paper on the polling place itself, one of them says you don't need an ID, one says you do. Sometimes, things are posted where you can't read them. So then there's polling. Then there's the third one is ballot design, and ballot design loses 1 million votes. Did in 2000, 2002, 2004, and that's really fun. I designed a ballot called Save, which when you make a mark, you see a confirmation. You see how many ballot races you haven't made selections on. It reduced errors by 1/3, and for people with reading disabilities, which is 14.5% of voters have dyslexia or something like that, it reduces their errors by 3 times. Now, when I did
electronically, or
that was electronic.
Okay.
So by the way, and we can get into the electronic stuff. That's a very long, complicated. I spent lots of experiments determining what happened in various allegations of fraud, and most of them were user interface design. But when it became hard to use my electronic solutions, I made some other solutions. So this is a very interesting physical one. The light, it turns out, is very important for people with bad sight. You can really improve your acuity with light. The magnifying glass, being stable and sitting on something, is helpful for people with tremor. It's also helpful for people with dyslexia, because the most important thing you can do for people with dyslexia is structure their visual search. So when you move this down the ballot, that gets rid of almost all the problems that dyslexics have.
Because they see one line at a time.
Yep, that's right. Okay. And furthermore, the people that don't have glasses, by tying this to the ballot booth and making these non-textual instructions, it's always in the polling booth. I've watched hundreds of polling places, and what happens is, if you go into a polling booth and you shut the curtain and you don't have your glasses, you're just embarrassed as hell, and you just don't vote. So by having the magnifying glass there, you solve that problem. So it's funny that, here I am again, like I've said several times in this, I've made electronic solutions, and then I've made physical solutions to the same problem. And I made this for the Election Assistance Commission, and some of them, a few thousand of them have been used. But quite frankly, there's a lot of problems with the paper ballots as well. And the security of paper ballots is very poor, or it takes a lot of care to get right. And counting of them.
Security in what sense?
Security in that ballot boxes get lost.
Really?
Yes. And security as in, I watched an election official taking a whole bunch of ballots with a pencil, going into the back room to look them over and bringing them back. Okay. Security as in, when in the state of Washington, the state governor was won by 9 votes and they had a recount. Each time they recounted, they got more ballots they found. Okay. Security as in, I have a election official that watched the counting in the state of Washington during that situation. There was a guy and 2 women counting ballots. And each time they'd go a little group, he'd have a couple more for one person. And he wore a suit, and after a while they'd accept a couple of his votes a couple of times. And when the whole race is running on a few races, anybody making, even if there's 3 people counting, there's intimidation possible. So, security as in the state of Oregon, there are, when I watched it, I saw 9 places after they closed the door and the truck was inside the polling counting place. 9 times people's fingers touched these ballots. Now maybe that's changed by now, and no one puts lead underneath their fingernail and marks a ballot afterwards. So everything has problems, and basically multiple. I've written lots and lots of papers about voting, and I've done lots and lots of studies. Basically, single agents aren't allowed, in my view. If you have one person logging onto the back-end network, you've got a security problem. If you have one person looking at a ballot in that room I told you about, you've got a problem. And so that's my biggest thing. I worked on the voluntary guidelines. I worked on getting the Election Assistance Commission started, but it's never been as difficult a task. Anything is, I guess, my political scientist friends that worked with me at MIT and Caltech and Harvard all said this was more political than anything they've done in their life. So,
and the stakes are high.
The stakes are high is the whole point.
Yeah.
But so I made my last stint in this is that I made 5 different kinds of technologies for people with disabilities to vote. Audio voting is an interesting approach, and polling place operations that are really extremely much more difficult for people with disabilities than other people, And there's a lot of so I have this internet way of doing that. I also made a nice tool for testing your web page for accessibility. And instead of telling you all the things you did wrong, it shows you it shows you what the implications of your mistakes are, so you can just change them easily. So I made a lot of different things like that, and had a lot of fun. And I'm still busy trying to get the Election Assistance Commission to consider deploying things like my magnifying glass and some of these other things. By the way, my biggest success in voting was that I worked very closely with the Chinese elections to help them design their voting equipment. And I didn't realize I was doing this. It's just this guy kept sending me these papers, this like thick paper with everybody's work on it in it, that it worked on voting all over the world. And he kept saying, well, what do you think of this? And I kept, I'd mark it up a little bit. And then finally one day he says, well, I made my decision. It's like, and I met this guy. He wasn't even 30. He was in charge of all the voting systems in China.
Wow.
And to give you an example of what he did right, they are paper voting machines.
Okay. Machines.
Yeah, the ones that scan a piece of paper, the paper scanners.
But you fill in by hand.
Yeah, you fill in by hand, and then hopefully nobody else grabs it, as they did for me once, and start looking at it. But I had a voting official do this once. Anyway, what theirs does is it reads the words that you read. So instead of it having a template type and having a position, there's no indirection. It does OCR, and that's the big damn deal. That's the future of paper ballots, because then you are marking not the. I've seen where people were given the wrong ballot. Okay.
How can that be a wrong ballot
if you have
polling place?
There's something called a split precinct in Chicago and other places where you have the dog catcher in this part of the precinct, and those guys have the water bill in that part, and then they'd have 2 ballot booths, and you get the right, you're in A or you're in B, and if you get them mixed up and you put them in the wrong scanner, and in one place they had not labeled which booth was supposed to go to which, so people just randomly putting them in, and it only affected the senator and 1 or 2 other races, so it's
bizarre.
Yeah. There's lots of problems. And then, I've seen people putting their hands into these ballot boxes when they aren't scanning right and pulling the scanned ballot in. Did it get scanned? I can get into a lot of detail about this, but yeah. High-speed scanners, if they jam, which ballot got scanned and which one did you not yet scan?
Yeah.
So some places they put numbers on them so you can know, and some places it's illegal to put labels on the ballots because it could identify.
Yeah, I guess, as you said in the beginning, it's something that's done rarely, right? And it's nobody's, or it's very few people, it's their direct job that they do all the time, right?
Well, what's interesting is people always give shit to the older people that are running polling places. Those guys are mostly the best. Those guys, because they've done it and done it and done it. And so I find the 70 to 80-year-old group are the best poll workers often. It is interesting. I mean, the real thing I take home is whatever you do, check it again. So my buddy, Don Norman, a famous user interface guy, he told me a story, which is that just, at that time when everyone was thinking about it so hard, he was in a hotel and he filled out his paper ballot, and his wife filled out her paper ballot, and then they checked each other's, and they, against the template that they both said they were going to do, and they each found an error. And so that's why the confirmation. So one thing I did, people want to talk about a paper trail. Well, I made an audio verification. In fact, if you look at my paper in Scientific American, it talks about this, where when you type Smith and it says Schwarzenegger, you know you made a mistake because it's a different modality. And I did an experiment comparing paper and audio. And audio confirmations is not a crosstalk of reading and comparing. It's simultaneously different modality that are disconfirming, and we found 80% of people with audio could distinguish the difference, and 15% of people with paper. So big difference. And the reporting was even worse. The paper people, well, anyway, it goes on. 0 of them actually said there was a problem. So it's very, very, a lot of these ideas that people have come up with and promote very heavily with even big funding weren't as big a solutions as people were hoping for improving voting. And
Like
it's a
the
long journey.
electronic voting machines.
The electronic voting machines reduce the amount
They could have
of
everything. They could have the feedback and.
Yeah, that's right. And in fact, we have some good data about them, and I shouldn't be getting into this, but I'm going to say it anyway. In 2004, we got the data that said that the best that anyone did, any state that used paper marking, close to 1% of people didn't succeed at voting for the top race. That's so 0.9. And the places that used electronic, they used 4 different equipment: Sequoia, Diebold, ES&S, and a mixture at Nevada, Maryland, Florida, and Georgia. All of them got 0.4% or less. So we took Georgia, which in 2000 had 3.2% of people go in and not select a president. And I can tell you all about it. It's a long story full of messes.
Every 30th vote.
Yeah, that's right. Down to 0.4. And by the way, in 2000, the best political scientists in the world said it was not possible to have less than 1% because people go into the booth and do what's called a protest vote. And suddenly in 2004, we have this tremendous change for the states that have electronic voting, and then a big political movement stops that, and we're back to voting on paper.
What do you mean? That was mixed?
Many states it's illegal to use electronic voting machines. Yeah, 27.
And that came after the 2004?
That came after, yeah, that's right. And it was just a big political movement by people that hadn't done experiments and were security, people. Yeah.
I guess you'd have to prove that it's secure, right?
Or you have to prove that it's insecure.
Yeah.
So
right.
you look for fraud in various ways, right?
Mm-hmm.
And I think that you use multiple methods, and you make sure that no one can make the mistake that happened in Volusia County in 2000, where one person got rid of 16,022 votes on a back end system. And by the way, CNN caught it because they had the data from before these disappeared and after. And so that's an example. When you have, because before that, nobody had this electronic stuff which had these records, and nobody had these partial things. On the other hand, what the heck, is there any software in the world that lets a voting official do that? And my frustration is I have not been successful at getting the security community or the voting community to legislate that nobody should be able to vote, should be able to set up or change any voting system by themselves, right? That there has to be interlock. That interlock, doesn't matter. We're using paper, we're using electronics, we're using anything. We have to have people supervising each other to have non-fraudulent elections. So so it goes on and on. But I worked hard on this. I was the co-director of the Caltech MIT Voting Technology Project. I ran many workshops, including election officials and federal election people and election companies on these topics. Unlike some of these other people, until I was pretty much out of it, I didn't take any work in this area because I really wanted not to have any taint. I think I dreamt it was going to be my public service. It was going to be my civil duty to go and I thought that actually, wrongly maybe this Chinese example is the good one though, that voting technology would be a cheap, useful thing that America could export that would help democracy. That was my idea. There's
I hadn't
IFAS.
thought of it like that.
Yeah, that was my dream, is that I'd be helping the world. But anyway, hopefully it's had some effect.
Okay. Anything else from your MIT time that you have stuff to show?
Well,
Or is there?
I have lots of things. I taught a class called Industrial Design Intelligence.
Okay.
And I've always loved physical design, and this is just a simple example of something that kind of repurposes something again. And it was kind of neat to put the whole results of a conference on a disk and have that be your label, and then you see you can put it on like this. Okay. And in fact, they used to have pins on them too, so you could pin them on.
Name tag, yes.
By the way, I always had them with red pins to TrackPoint.
That is the TrackPoint. I was wondering.
But this is all it is. And I think what's really fun about design is it's in its value that comes from what it does, not what it's made of. And so I spend a lot of time teaching students the value of thinking about the need for whatever you design to have a functional purpose, an aesthetic component, and an evaluation. And the thing that's interesting about aesthetics is aesthetics can be part of the messaging. That is, it teaches you what to do, how to do it. It's a memory aid. It lets you understand what its value is. It reminds you that it exists. And then evaluation. Historically, the human factors people test things that the engineers make, and they don't know how to design from an engineering point of view, so they don't have much say. And the aesthetic people are looked down on by engineers because they're just making things more expensive. And I really try to teach, when I'm teaching product design, I try to say that the more you can integrate it into your head, instead of the multidisciplinary approach. Multidisciplinary approach, D-School, everything's great. The idea of bringing in lots of people, different points of view, great. But what's even better is if you hold multiple ideas in your head and you let them compete. And so another example of a simple, kind of transformation is this is a ball that I've used in many conferences I've run. And this ball is called Flying Mic. You can buy them from me. And you put the lavalier mic inside of here, and this is where the microphone lets the sound in, and you just toss it to somebody. And they catch it, like you just did, and you can toss it back now. And now I catch it, and I say, I'm here. So the really great thing about this is I'm thinking about the scenario. When a person's going to speak, I give them a 1-second opportunity for everybody to pay the attention to them. They watch the ball going to them, and then that person speaks. When I want it back, I put up my hands, you send it back to me. I'd never told you about this. And I get the microphone back. So now, instead of lining up people in the aisles to ask questions, what we have is a conversation that ping-pongs around a conference room. So that's the kind of thing I was trying to get people to do. I teach courses on that kind of stuff. MIT also was a lovely place for me to take what I learned at IBM about creating a way of bringing innovation and business together, and I brought it to the National Research Lab of Taiwan. I did, lots and lots of, Mars, Campbell, Merloni, Postal Service. So dozens, Motorola, lots and lots of companies. I would sit down and try to help them think about innovation and invention. And so that was a little piece of my life when I was one of the top producers of funding for the Media Lab for many years. And I had a lot of fun getting inside the heads of these different sponsors. But the thing that I was most, I think was one of my biggest successes also, besides the students are always the great big success, is recognizing that all of those platforms, the smart car, the smart kitchen, the smart bed, all these smart things that I've been telling you about, they succeeded when the social feedback was not inappropriate. And so even when you see this ball flying to you and giving you a valuable thing that you talk into, that makes the silliness of the color not so upsetting. It also, it's kind of, it kind of is a confluence of things working together. So I started a research project at the Carnegie Mellon Silicon Valley called Considerate Systems. And Considerate Systems is all thinking about what we can do to make social feedback succeed. And I have a bunch of demonstrations now and research projects that show that if you have social feedback, it can improve lots of kinds of interactions. So there's a book called Peripheral Interaction that I helped edit that talks about the idea that maybe the most important thing about interfaces is not that they take your attention and I'm so important of an interface, but that they hang back as much as possible, distracting you as little as possible till they need to. Like my story about those IM messages that I was talking about earlier. And so I have a bunch of examples of that, even ones that could be useful for improving driving that I've made.
So I was going to ask you how would you define social feedback? Is that because there are multiple people and everybody sees who gets the microphone, or
that's an example. But social doesn't have to be multiple people.
Okay.
All that social has to be is being respectful of the person that you're communicating with, right? And social feedback's a much more broad term than considerate. There's passive, considerate things that just know, thank you for, the simplest one is the 1930s example of a door that opens when you go up to it with a basket of groceries. And so now we've got this, we recognize that you need something. Opening a door is a social statement already. And so we end up with these things working together. Active one, so just saying welcome to each person that comes in, often what a maitre d' does. But if you look a little pale and say, welcome, would you like to sit down for a moment? That's the next level. That requires feedback, that requires interaction, that requires sensing. And so active, we talk about active and passive social. We talk about considerate things that have a model of the social interaction. And as long as I have a model and I'm not inappropriate, I do better. And that's kind of what I'm very excited about that. And it's something that I actively work on, still doing research projects in that area.
And so you've already mentioned Carnegie Mellon. That's after MIT, right?
Yes.
So
yes.
I guess we're in the time after MIT now?
We're in the time after MIT, and we're in the time after Carnegie Mellon. At Carnegie Mellon, I put together I helped put together the Ph.D. program, and I used to mentor all the faculty. It was great fun building it up to $7 million a year of funding from zero. But I left there as it turned more electrical engineering, and I do electrical engineering, but I care about cognitive science. And now I consult. I was in Perth, Australia, working with Curtin University on lecturing and working with professors just last week. So I continue to work at different universities, but I also do a lot of my own stuff. I've always been an inventor. I'm always building. My hands are always dirty. I guess I want to show you, just for the fun of it, a couple of things that I just did on my own.
Okay.
So one year I took off part of a year when I was in college, and I made this. And this was to plug into the dome of a car and be a rechargeable flashlight. But that was kind of a fun little project I did. Even earlier, when I was a child, my father showed me a machine that would spray nylon. And he was working on non-woven fabric. So I put my hand underneath this thing and I made a glove, and it was very warm. And I wanted to make a machine to make this is when I was in 13. I repurposed some things. And you'll see that there's a little bit of nylon still on this stupid heating element. This thing didn't work very well. Not as good as the one the factory had, but I dreamt of making clothing that you would just spray on yourself.
Oh.
But that I just didn't have the organization enough to do. And now, by the way, just this year, there are several forays into that. Companies that are actually thinking about how to spray, selling something to spray on. But the most recent thing that I made this year is only part of it. I just didn't want to bring the whole machine. The machine is a bucket you put your leg into. This is a sensor that is ultrasonic sensor that goes around your leg. So if you have a leg sitting in here, goes around your leg and uses this robot with this computer. If we had a USB battery, we'd be running it right now, to scan, to build a really good, coherent image from ultrasound. And the reason that I'm making this is a bunch of reasons. First of all, last 2 years ago, I made, as a consulting project, I made a shirt folding machine, 21-axis robot. You probably heard about Foldamate. Very complicated. This year I made a pill compounding machine with Daniel Kraft, 17 different pills it can put together. I wanted to make something simple. This is pretty much one-axis robot. It just goes around a hoop. And what can it do? It turns out that actually, for a lot of purposes, ultrasound is better at soft imaging than MRIs. It's, orders of magnitude cheaper. It has been difficult for people to use because they hold it in their hand. So this takes that out of their hand. It's been difficult to use because the imaging doesn't go deep. And by making a compound image, I'm able to do that. I've got a better sensor. I'm working with Interson, a fantastic sensor company. So I'm kind of excited about that project. And that's an example of something I'm
now
doing.
it does
right now.
only a cross-section of where you are.
That's right.
And so you have to kind of push your leg through to get the whole leg?
If you want to get the whole limb. This says 128 sensors, so it's actually 128 points with a focused beam. So if I want to look at my Achilles tendon, or if I want to look at my meniscus might be harder. If I want to look at, for example, I have a epicondylitis that was bad for 20 years, but I didn't want to spend money on an MRI. When they finally did it, I only had 20% of my gripper left. They did a little surgery here. That's a very simple thing for something like this to identify, or maybe my tunnel carpal that I had to get fixed, those kind of things. It's a lot of things that we don't actually get imaged, and quite frankly, this thing is battery operated, and see the battery, lights on, and I envision that it could be possible to take it to a sports field. 23% of people that are serious sports field players will have some problem with their Achilles while they're playing sports, and it'd be great to know whether it's ruptured or just sprained. And the other thing is it's much faster than an MRI. So this is, just a minute instead of those MRIs can be quite. So that's my excitement. Maybe I shouldn't be talking about it too much yet, but anybody's interested in helping me with that, that's something I'm having fun with.
And for that, you have your own company?
Yeah, I'm Selker Design Research. So I'm always building prototypes. I've got lots of prototypes laying around, things that I'd love to take to market, and sometimes do. But then, I also consult for big companies like, at this moment, Magic Leap and Sentient and a couple of others. Yeah.
Okay. I know you got lots of awards and things. How about talk about a few that you are most proud of?
Well, that's really sweet of you to ask. You know, every celebration helps us feel good. And, you know, whenever a student would come to me and tell me later in their career that I'd helped them earlier, I mean, oh my gosh, it makes me so happy. Or anybody else. So those are often, it's the personal thing. So in fact, helping Joe Rutledge retrain himself from being an algebraist to working on this TrackPoint, I mean, the ways in which he and his wife appreciated that and the impact we made, and you can just watch it in his steps. So I think career development is always my favorite reward. I was, you know, very honored to get this to be an IBM fellow. There's, I guess, probably at this point, at the time I did it, there was 150 ever in the history of the company. Now maybe it's more. Maybe there's 200 something. But that was really cool. And it was cool because people treated me well. You know, it's about how people treat each other that matters more than anything else. I got access to, you know, so many opportunities to make things better through that. The Scientific American Award, I was proud of that.
What was that?
That was a policy award around voting. I was a Scientific American 50, so that was a pretty exciting award. But I'm not sure it changed anything. When
Maybe
you get an
not yet.
award, people actually are often jealous of you, and sometimes it can make things worse. So I got something called the Thomas Paine Award for Disabilities. It was given to me by a senator in the Russell House, and I was, you know, it was a pretty cool thing to get. Did it change anything about my life? Nothing nearly as big as the things I just, you know, the things that where I was doing things with people, I got several other, you know, exciting things. You know, Best Paper Award can be a lot of fun, and yeah, I think really, you know, the biggest reward was watching when millions of my product get used by people, yeah, I want to say, so my PhD work, which is this complicated AI system for help, it's in every OS2 shipped, right? They still ship probably, you know, 500,000 of these a year.
Really?
Do I ever hear anything about it? No. So the impact of people noticing something that you did is a lot of fun, and that's been the fun. And so I used to think that one of my biggest rewards was something like this, where I get on, have a public forum, and it's on TV and stuff. You know, it's hard to know. I think that actually it's the things that mattered to people, because these videos, how much do they get watched, and who wants to take the time to watch me for 2 hours? I hope you do. But I think those are, yeah, those. And you know, getting invited to be a professor at, you know, Stanford and MIT and CMU, I think those are incredible achievements from my personal, you know, feeling good about things. Getting my PhD, I hate to say it, well, my undergraduate I think was the hardest degree I ever got, and my PhD was a lifelong achievement for my, you know, for my father as well as for me, you know, and that kind of felt great, even though maybe it was not the best choice of things to do. In other words, if you carrying these dreams from preconceptions, you know, isn't, I mean, would have I done better by not spending 12 years of my life chasing a PhD? I would have, yeah, I could have been at Google, I could have been at Sun, those are places that invited me, but I wanted to get this stamp. Did anything change for me when I got my PhD?
Well, but
Hard to
would you always think I should have, if you hadn't, right?
Yeah. Furthermore, I want to say one more last little thing, which is after I got my PhD, I realized that when you talk to somebody that has a PhD, you can tell. the depth and rigor that is required, there's a lot to learn from it.
Yeah.
But then sometimes you get rigor other ways.
Okay, well, thank you very much for the interview. And since you're not done inventing, we maybe will have you back in 10 or 20 years.
Oh, good.
Or something
I
different.
can't wait.
right?
Yeah. Well, that'd be fun.
Okay.
And it's great. It's great of you, the gracious host, and I appreciate all the work you put into this too.